Hi, this is sixth video in this series. In this video, I will be solving questions from UPSC Civil Service 2023 GS2 paper, commonly known as CSAT paper. Previously, I have solved CSAT papers from year 2013 to 2017. If you're interested, you can find those videos in my playlist. In this video, I'll be solving max-based questions. That is, except for the comprehension type of questions, all questions will be discussed in detail. We had 53 such questions this year. Those questions can be roughly categorized into two: reasoning and analytical ability category and general mental ability category. We had 37 questions from reasoning and analytical ability category and 16 questions from general mental ability category. Usually we have data interpretation questions too, but there was no such questions this year. In my opinion, this was one of the toughest CSAT exam we have seen in recent times. People who haven't prepared well for this CSAT exam, or people who are not very familiar with the concepts like permutation and combination, people who don't have a non-engineering, people who don't have an engineering background or who are not good at mathematics would find this paper extremely difficult. Not just because of the difficulty in concepts, but because of the way the questions are being framed. Most of the questions were time consuming questions. The question itself was very lengthy and the answer was not very easy too. So I wouldn't be surprised if a lot of aspirants found this CSAT exam really difficult. So I hope this solution will help people who found the CSAT exam difficult, or people who usually find CSAT exam difficult, helpful. I hope this video will be helpful for the aspirants. And I have discussed the solutions in detail, but the official UPSC key has not yet been released. So there could be some errors. If I have tried my best to not have errors, but if you still find any errors in my solution, do comment under this video. I will look into it and redo the video if necessary. If you also have any other feedbacks, do share. It would be helpful for me to make future videos also. I hope this video will be helpful to all, and that's it. Let's take up the question without wasting much time. We have 53 questions to solve, and thank you for watching this video. So first question. Question number 1. There are 4 letters and 4 envelopes, and exactly one letter is to be put in exactly one envelope with the correct address. If the letters are randomly inserted into the envelopes, then consider the following statements. 1. It is possible that exactly one letter goes into an incorrect envelope. 2. There are only 6 ways in which only 2 letters can go into the correct envelopes. Which of the statements given above is or are correct? So 4 options are given. So we have 4 envelopes and 4 letters. It is said that the letters are randomly inserted into the envelopes. So the statements given are, first statement is, it is possible that exactly one letter goes into an incorrect envelope. What does that mean? One letter goes incorrect. So only one letter. So this only is very important. Only one letter goes incorrect, goes into an incorrect. That means, that implies 3 letters went into the correct envelopes. Okay. So is that possible? So we'll just randomly pick 3 envelopes, say this, this and this. So we inserted the 3 envelopes, correct envelopes. So the only possibility that is left is for the 4th one to go into the correct envelope. We cannot have any other choice. So 3 letters going into the correct envelope and 1 letter going into the incorrect envelope is not possible. So statement 1 is false. So let's see statement 2. There are only 6 ways in which only 2 letters can go into the correct envelope. So we have 4 envelope. Let's number it 1, 2, 3, 4. And the cases only 2 letters can go into the correct envelopes. So let's see how many ways we can choose 2 envelopes that are so 2 envelopes that 2 letters, the correct letters went into. So the number of ways, 2 envelopes, 2 envelopes where number of ways 2 envelopes can be selected. Okay, where 2 letters were correctly inserted. Where 2 letters were inserted is 4C2. So what is this 4C2? 4 into 3, 2 into 1, 2. So total 6 ways. So we can choose 2 envelopes in 6 ways. So that is like 1, 2, 1, 3, 1, 4, 2, 3, 2, 4, 3, 4, 1, 4, all the combination, all the 2 pair combination. We can select 2 envelopes in 6 ways. So in each of the 6 ways, so first case let it be 1 and 2. And in each of these selection, each of these 2 pair cases, we are left with 3 and 4, 2 other envelopes. In these envelopes, it is said that there are only 6 ways in which only 2 letters can go into the correct envelopes. What are the number of ways in which we can insert the envelopes in an incorrect manner? So third letter should be placed here, third letter should be placed here, and fourth letter should be placed here. Here we place 1 and 2 correctly. So in each of the 6 pairs, we can find only one manner in which 2 letters can be inserted correctly and 2 letters can be inserted incorrectly. So that is the only 6 possibilities that we can do to such that there are only 6 ways 2 letters can go into the correct envelope. So if you list out all the 6 cases, you cannot find another case where 2 letters go into the correct envelope and 2 letters go incorrectly. So that is, so I will just, if you are not didn't understand, 1, 2, so 1, 3, envelope number 1, 3, envelope 1, 3, third case will be 1, 4, fourth case will be 2, 3, fifth case will be 2, 4, and sixth case will be 3, 4. So no, these are the 6 possibilities. So in all these 6 cases, we insert the other 2 envelopes wrongly. So 1, 3, we will place 1 here, 3 here, and for 2, 4, we place 4 here and 2 here. So 1 here, 4 here, and for 3, 3, 2, we place 3 here, 2 here. Similarly, for all these cases, we can insert the 2 correct envelopes here, and the 2 other envelopes we can insert it wrongly. So all these 6 are the cases that is possible. So there are only 6 ways in which only 2 letters go into the correct envelopes. This is true. So the correct answer to question 1 is option B, 2 only. Next question, question 2. What is the remainder when 85 into 87 into 89 into 91 into 95 into 96 is divided by 100? We are given 4 options. So what we do is first see if we can get 100 out of all these numbers. So 100, to form 100 we have a 5 here, another 5 here, and 5 into 5 is 25, and we have a 4 here. So the idea is we just get from 85 we get a 5. So 5, if you divide with 5, this becomes 35, which is 17, right? 17 to 5. I write 85 as 17 into 5, and 87 as 87 itself, 89 as 89 itself, 91 as 91 itself, and 95 again I take 5 out of it. So 5 means 145 is 9, 19 into 5, and 96 I write 4 into 96 by 2 is 48, 48 by 2 is 24, so 44 into 24. So from this is exactly this number. Now as you can see, 5 we have a 5 here, and we have 4 here. Product of 5 into 5 into 4 is what? 25 into 4, 100. So that means 17 into 87 into 89 into 91 into 19 into 24 into 100. So some huge number into 100. So we will have 100 here. So if you divide it with 100, 100 and 100 cancels. So the remainder will be 0. So remainder will be 0 in this case. So the correct answer to question 2 is option A, 0. Next question, question 3. What is the unit digit in the expansion of 57242 raised to 9 into 7 into 5 into 3 into 1? So here we have a large number, and it is raised to another large number. So it only asks for the unit digit. So the unit digit of this number is 2. So in such cases, what we can do is, this number when multiplied with itself one time, what happens is the unit number gets multiplied with 2 again. So example would be 57242 into 57242. What happens is the unit digit of this product is nothing but product of 2 into 2. So we get 2 here. Again we'll get a number, and if we multiply again with 242, we again so 2 into 2, we get 4 in its unit place. So if you multiply again with this number, we get 4 into 2, 8. Similarly, if we again multiply, we get 16. So 16. If you, as you can see, the unit place becomes 2, 4, 8, 16. Then again, if you multiply with 2, 12. So it repeats. This 2, 4, 8, 6 gets cycled. So whether the unit digit is 2, 4, 8, 6, how many times we multiply 57242 with itself is the question. If it is multiplied only, it is not multiplied 0 times, it is 2. If when it is multiplied with itself, that is 2 times, it becomes 4. 3 times it is 8. 4 times it is 6, and 5th time again 2, 6, 4, 7, 8, 8, 6, again 9, 2, 10, 11, 12, and goes. So this is what happens. So it will be, the unit place will be either 2, 4, 8, or 6. So as you can see in the options, all the 4 are given. So we have to find which. So we will calculate the product of this first. So 7 into so here 7 into 5, 35, and just calculate the product. 9 into 7, 63, and 15. 5 into 3, 15. 5 into 3, 15. 6 into 5, 30, 31, 3, 6, 5, 4, 9. So product is 945. So to find in which this comes, we divide this number with 4. So the remainder, we see the remainder when we divide it with 4, we will see what is the remainder, and that remainder, if it is 1, it will, the unit place, it will be 2. If the remainder is 2, it will be 4. If the remainder is 3, it will be 8, and if the remainder is 4, it will be 6. So as you can see, 945, the closest number that divides with 4 will be 800, 140, 940, 944. So 944 divides with 4. So remainder will be remainder, if you divide this number with 4, remainder will be 1. Remainder 1. Dividing by 4. Okay. Dividing by 4, remainder will be 1. So that means the unit place will be 2. So our answer, our solution to question, so it was question 3. Our solution to question 3 was A, 2. Next question, question 4. If A, B, C and D, E, F are both 3-digit numbers such that A, B, C, D, E and F are distinct non-zero digits such that A, B, C plus D, E, F equal to 1111, then what is the value of A plus B plus C plus D plus E plus F? So it is given A, B, C plus D, E, F is 1111. And it is also given they are distinct and non-zero. So we have to find A plus B plus C plus D plus E plus F. So as you can see, C plus F has to be 11. It cannot be just 1, because C plus F being distinct and giving a sum 1 means either one of them is 0 and another one is 1. So since they are non-zero distinct digits, C plus F cannot be 1. That means C plus F has to be 11. So in that case, we'll get 1 in unit place and we'll get a carryover 1 here. So from that we can get B plus E has to be 10. So B plus E again cannot be 0. So B plus E has to be 10. So 10 plus 1 will give 1 here, and again a carryover 1 here. So A plus D will again be equal to 10. So as you so if you see the LHS, if you take the sum of all the LHS, what we will get? A plus B plus C plus D plus E plus F. So which is what we need to find. This is equal to sum of all RHS will be 10 plus 10, 20, 20 plus 1, 31. So 31 is the answer we need. So solution to question 4 is D, 31. Next question, question 5. If D is a 3-digit number such that the ratio of the number to the sum of its digits is least, what is the difference between the digit at the hundreds place and the digit at the units place? So we have a 3-digit number, let that be x, y, z, and the ratio we are interested is x, y, z by x plus y plus z. So this ratio has to be least or the smallest value. So for this ratio to be small, x, y, z has to be small, very small, and x plus y, z has to be large. In that scenario only, this ratio become the least. So from that itself, we can assume x has to be very small, since a large value of x will give a very large 3-digit number. So no matter what, since this is a sum, no matter what the x is, when you do that, you will get a very large ratio. So x has to be very small. X cannot be 0, then it will not be a 3-digit number. So ideally x has to be 1. So we are looking at a number somewhat like this, 1 plus y plus z. Now a number starting with 1 and denominator has 1 plus y plus z. we need to find yz value such that this will not increase this value beyond the limit, and y plus z has to be very large. So now the largest possible value for y plus z is 9 plus 9, which is 18. Or the smallest value, again, since we need to maximize yz, y and z, and since we already have one, another combination we can think of, since we need to minimize yz also, y to be 0 and z to be 9. 0 plus 9 will be, the denominator sum will be 9, sorry, denominator sum will be 9 plus 1, 10, and top will be 109. So 100 and, so we'll just check both the combinations. So 199 by 1 plus 9 plus 1, so 10 11, sorry, 9 19, so this becomes 199 by 19. This is 10 90 19 into approximately 10.4. So 19 into 5 is 95, so 90 becomes 10.4. This is one value. So in the second case we have 109, so this becomes much smaller than 199. So but the sum in the denominator also reduces drastically. So 109 by 1 plus 0 plus 9 gives ratio as 10.9. so this ratio is much smaller. In this case the difference between the unit and the hundreds place is 0, and as we have seen, this is 10.9, and we can randomly select two numbers so that the difference is 7, and check whether the ratio is higher or lower. Probably this has to be the lowest ratio in this case. So let's check one case. So let's check 9 2. So 9 minus 2 is 7, so we will get the difference 7. So 10 12. So as you can see, this ratio is much larger. 12 gives 72. So 15 plus, this is 15 plus, this ratio is 15 plus, so this is not the answer. So as you can see, when we pick some random number, some other numbers, it is getting larger than 199 by 19. So probably this has to be the lowest ratio number, and it fixes with the idea that 1 plus y plus is getting large, and y z, though 1 y z is very large, is also got bigger. As we have seen, when we try to minimize y z, we don't get much gain in reducing the ratio. So this has to be the answer, 10.4. So our solution to question 5 is the difference between unit and hundreds place will be 9 minus 9 0. So A has to be the solution. So solution to question 5 is A. Next question 6. 3 of the 5 positive integers p, q, r, s, t are even, and 2 of them are odd, not necessarily in order. Consider the following: p plus q plus r minus s minus t is definitely even. Second statement is 2p plus q plus 2r minus 2s plus t is definitely odd. Which of the above statement is or are correct? So we are given that out of all the 4 given integers, 3 of them are even. So I am writing even with E, and 2 of them are odd. So we will be using the concepts like E plus O equal to odd, E plus E equal to E, O plus O equal to E, E minus O equal to odd. Similarly, we have all the combination, right? We will be using this combination to solve this. So we will take up the first statement, p plus q plus r minus s minus t. So we will split that into 2 scenarios. So we will write P plus Q plus R and S minus T. Okay, before that we'll just write S T and S minus T just for clarity. So for S and T we have various combination. S and T can take since we have 3 even and 2 odd, it could be either 2 even and odd. Odd even, it doesn't, even and odd even will be the same case here in the given example, so it doesn't matter. So or odd we'll be checking these 3 cases. In these 3 cases, since we this P plus Q plus R will be sum of what? Sum of 2 odd, already 2 even gone, so 1 even left, so 2 odd plus 1 even. So 2 odd numbers addition of 2 odd numbers will give an even number, plus an even number will give an even number, is equal to an even number. In this case it will be an even number. So P plus Q plus R will be an even number, minus even number minus even number, so this will be an even number, so total will be an even number. Output, so I will write output out will be an even. So in this case it will be an even. So we will check this case. So 1 even and 1 odd is taken out, so this will be 2 even and 1 odd. So 2 even plus odd will give an odd result. And even minus odd, e minus o will give an odd result. So odd result and an odd result. Subtraction of odd and odd will give an even. So here also we will get an even number as an output. And let's check the last case of odd. In odd we will have this as 2 even plus 3 even numbers. So sum of 3 even numbers will be an even number, and subtraction of odd and odd will give an even number. So E minus E will also be an even number. So in all these cases, P plus Q plus R minus S minus T, this is the output, P plus Q plus R minus S minus T. That is this minus this is this out. So even minus even, odd minus odd, even minus even. So in all these cases it is even. So statement 1 is true. So let's take statement 2. In statement 2, if you see, there is 2p, 2r and 2s. So 2p plus 2r minus 2s will be even. So whatever, no matter what integer p, r and s are, see 2p will be even, 2r will be even, 2s will be even. So even plus even minus even will be even. So this is an even number. Now to that we are adding q and t. So the statement is 2p plus q plus 2r minus 2s plus t is definitely odd. So we already have this as even. So in cases where q is odd and t is even, what will we have? Even number plus odd number. This will be an odd number. So in cases where q or t is even and odd, we will get our total output as odd. Sorry, what we need was to check whether this is definitely odd. So in that case we will take q and t as even numbers, or q and t as odd numbers. In both the cases, even plus even is even and odd plus odd is again even. So in both the cases, the total sum, this 2p plus 2r minus 2s plus q plus t, will be even. So this is a false statement. 2p plus q plus 2r minus 2s plus t is definitely odd, is a false statement. So solution to question 6 is A, 1 only. Next question, question 7. Consider the following in respect of prime number p and composite number c. First statement, p plus c by p minus c can be even. Second statement, 2p plus c can be odd, pc can be odd. Which of the statements given above are correct? So if you look at the statement 1, it says p plus c by b minus c can be odd. So the composite number here can be odd or even. Okay, if you take even number, p plus c becomes, p prime number is an odd number, odd plus even is an odd number, and p minus c will become again odd minus even, which is an odd number. So odd by odd, which again is an odd number. So in that case, it cannot be an even number. So for this to be an even number, p plus c and p minus c has to be, c has to be odd. So in that case, p plus c becomes an even number, and p minus c becomes again an even, odd minus odd is even. So this also become an even number. So this is an even number. So if at all we want p plus c by p minus c to be even, that means this composite number has to be odd. So, and if p minus c is 2, we can think of a number such that p minus c is equal to 2, or c is nothing but p minus 2. Okay, in this case, if you add c, if you do p plus c, considering c is equal to p minus 2, we have p plus p minus 2, or 2p minus 2. So 2p minus 2 is an even number. So 2p minus 2 by p minus c, which is 2, is equal to p minus 2. Sorry, p minus 1, which will be p minus 1 and p minus 1. That means this is an odd minus 1 is even number. So this is possible. So we can think of randomly, we can choose c such that c is equal to p minus 2. So if you see, we can think p as p equal to 7. C has to be composite. So we will think about 17, p equal to 17, and composite c is equal to 15. So 15 is a composite number. 5 into 3 is 15. So it is a composite number, and p minus c is 2 itself. So if you see, if p plus c by p minus c is nothing but 7 plus 5, which is 32, by p minus c is 2, or we have 16. So which is an even number. So p plus c by p minus c can be an even number. So this is a true statement. And 2p plus c, 2p is an even number, since this is an even number. If c is an odd number, then 2p plus c will be odd. So 2p plus c can be odd is a true statement if c is an odd number. So this is also true. So pc can be odd. Here it is, there it is, here it says pc can be. Okay, in this case, p is a prime number, and c, if c is also a odd number, then it will be odd into odd. So it will be an odd number. So 3 also true. So which of the statement given above are correct? Our correct answer will be D, 1, 2 and 3. That is the solution to question 7. Next question, question 8. A 3-digit number ABC on multiplication with D gives 37DD, where A, B, C and D are different non-zero digits. What is the value of A plus B plus C? If you look at the options are 18, 16, 15 and cannot be determined due to insufficient data. Whenever there is an option called cannot determine due to insufficient data, usually it will be difficult, it will be time consuming question, since we have to check all the possible scenarios and make sure that uh, the data is not insufficient and we can finally arrive at an answer. So we'll see what is with this question. So it is given a, b, c is a 3-digit number, and when we multiply with d we get 3 7 d d. So now what are the possibilities for d? D can take values from 1 2 3 4 5 6 7 8 9. These are the 9 possibilities d can have. And if you look at the question, it is given a, the last, this is one information we are given, the result, the product we get, the first 2 digits is 3 7. So from this we can eliminate few of the options. Since let's assume d is 1, what happens then? A into d plus some remainder we get when we multiply, sorry, not remainder, carryover. So when we multiply b with d we get some, we get d and then a carryover, right? And some carryover c is equal to 37, it's given. So if you see d, if d is 1 and even if a is 9, the highest value it can take, 9 into 1 becomes 9 and the carryover has to be greater than 10 or so high to get 37. That is not possible. So d cannot take value 1, so we can strike that off. Even if 9 into 2, if d takes 2, 9 into 2 is 18, still carryover has to be greater than 10. That is not possible. So even 2 cannot, we cannot take 2. 9 into 3 is 27, then carryover has to be 10, which is also not possible. So 3 will not be the case. So the possibilities of d starts from 4 till 9. So we will check each. So let's first take the case of 4. So if d is 4, what happens? A, b, c into 4 is equal to 3 7 4 4. That's what's given. So now it is easy to find a, b, c. Just divide 3 7 4 4 by 4. We get 8 into 4 32, 54. Oh sorry, 9 36, 1 14. So 4 into 3 12, 24 6. So 936. So we get ABC as 936. That is 936 into 4 is 3744. So we get one value for 936. So if you add, so question asks for a plus b plus c. So if you add 9 plus 3 plus 6, we get 9 plus 6 is 15. 15 plus 3 is equal to 9 plus 3 plus 6. 15 plus 3 is equal to 18. So we get 18. So 18 is one option. So the moment we get 18, we cannot mark 18 as our answer. We have to see whether any of these D options 5, 6, 7, 8, 9 gives a possible answer and gives another answer. If every possible combination either gives 18 or doesn't fit the given conditions, then we can say 18 is the correct answer. So but if it gives any other value, like say it gives 16 or 15 for any of these D values, then we will have to say the answer will be cannot be determined due to insufficient data. So we have to check that. That is the problem here. We will have to check all the combinations and make sure that 18 is the only possible result. So if you check, we already if you we have already ruled out 1 2 3. We have checked 4. Now what is left is these values. So we have already found a, b, c for value 4, which we get the sum as 18. Now we'll check 5. So when in 5, sorry, for 5 it is 3 3755. Here the value 37dd becomes, when d is equal to 5, it becomes 3755. And when we divide by 5, that is ABC into d equal to 37dd. So when d equal to 5, we get 3755, and to find ABC we just divide 3755 by 5. So we get 7 into 5, 35, 25, 7, 25, 5, 1, 751. We get our ABC as 751. So here ABC is 751 and sum is 8 plus 5, which is 13. Different value, but there is a problem here. D and so we got, this is our A, this is our B, this is our C. D and B value are the same, but in the question it is given A, B, C and D are different non-zero digits. So it doesn't fit the given information, even though we get a unique value for A, B, C. The given condition that B and D has to be different fails here. So we cannot consider the value for D as 5. So that also goes. Now if you check similarly for all other 6, 7, 8, if you check 3, 7, 6, 6 by 6, you can see it is not divisible by 6, since this value 10 plus 12 is 22. The sum of these 3, 7, 6 is 22, which is not divisible by 3, so it is not divisible by 6. So 3, 7, 6 is not divisible by 6. Similarly 3, 7, 7, 7 is not divisible by 7. You can if you check 3, 7, 7, 7 is not divisible by 7. Similarly 3, 7, 8, 8 it's not divisible. 3, 7, let me check, 6, 4 is divisible by 4, since last digit 2 digits is divisible by 4, but once 4 you divide with 4, it is there won't be any 2 left. So this is also not, we'll just show 8 into 4 is 32, 58, so 56, 28. So 28 is not divisible by 8, so it is not divisible by 8. Similarly 3, 7, 9, 9 is not divisible by 9 also. This is 19, 18, 19, 19 is not divisible by 8. So if you quickly check, it is not divisible by any of this combination D's values. So only possibility is D is equal to 4, and 5 is ruled out because B becomes 5 and one of our condition is not matching. So only possible combination is D is equal to 4, and our, in that case, A plus B plus C is equal to 9 plus 3 plus 6, 18. So we got our answer as A, 18. I accept that this is a time consuming answer. Sorry, I accept this is a time consuming answer, but we are seeing a lot of difficult question in this exam paper. So this is the only way I am seeing to solve this question. If you have any other easier way, do comment. I'll check on that. Anyway, solution to question 18 is A, 18. Next question, question 9. For any choice of values of x, y and z, 6-digit numbers of the form x, y, z is divisible by. So we have the number in the form x, y, z. So to get a number of this form, we know it has to be like this, into xyz into 1000 plus xyz. So if you do this, you get xyz. So xyz into 1000 is nothing but xyz into 30. So plus xyz, if you add xyz, you get xyz. That's why we can split this into this form. And if you take xyz common, we get 1000 plus 1 or xyz into 1001. So any number of this form is this xyz into 1001. So xyz into 1001, if you see 1001, you can easily see the it is symmetric and it is divisible by 11. So 1001 divisible by 11 is 11. You take 99. 11 1 91 91 11 into 91, and 91 is again, if you see 11, we have 7 and 13 here, so 91 is nothing but, if you see 13 into 7, 13 into 7 is 21 to 91, so 91 is 13 into 7. So 1001 is if you, xyz into 1001 is also can also be written as xyz into 11 into 13 into 7. So no matter what value xyz takes, this number will be divisible by 11, 13 and 7, since this number is nothing but xyz into 11 into 13 into 7. So for this question, 6-digit number of the form is divisible by 7, 11 and 13. So the solution is D. Question 9, D is the answer. And the reason is this. So that is the solution. Next question, question 10. 125 identical cubes are arranged in the form of a cubical block. How many cubes are surrounded by other cubes from each side? How many cubes are surrounded by other cubes from each side? So in this question, 125 identical cubes are arranged in the form of a cubical block. So usually when in the cube dissection problem, a cube of n side is split into equal parts. When the problem is like that, we know that the total number of smaller cubes will be n cube. So here n cube is given 125. N cube is given as 125. When 125 cubes are arranged into a cubical form, each side will have n length, that is n equal to, here as you can see, n equal to 5. So it will be of a length 5. In such case, when a cube is built like that, we will have, when a cube of length 5 is split into 5 equal, each side is split into 5 like this, we will get 125 smaller cubes. So that we have n equal to 5, and how many cubes are surrounded by other cubes from each side, which is same as like the question, the usual questions we see is of a similar question we see is asking for the number of cubes that has no side painted. They will ask all the cubes are painted, and when we open up, what is the number of cubes that are not painted. It's the same kind of question, worded differently. And to understand that clearly, I will just show you a picture. See, this is the cube. I have arranged the 125 cubes and opened it up to clearly understand what is going on here. So I have cut it open. First we have arranged that smaller 125 cubes into a bigger cube, and I have cut it open to show what is the number of to find the number of cubes that are surrounded by other cubes. The cubes that are colored yellow are the outer cubes that that will have that will be opening to outside. So these cubes won't be surrounded by other cubes, but the cubes colored red, every cube colored red in this picture will be surrounded by other cubes in all sides. This is the number they are asking for. So when you cut open the cube, you will see clearly what is the number of, what is the cubes that are surrounded on all sides, which is same as finding the number of cubes that are not painted when outside of the cube is painted. So that is why I said the formula is same here. Once we find n equal to 5, you can see I'll just use a different color. The length of the cube, what we want is length, breadth and height of the cube. This one, this one, this one and this. So for that this length is nothing but n minus 2. This is nothing but n minus 2, and this is nothing but n minus 2. Here this one is n minus 2. Since we removed since there was an cube here and there was a cube here, we removed those two. That is why n minus 2. Here, as you can see, we removed one cube here, right? And we removed one cube here. So this length is nothing but n minus 2. Similarly, this length is nothing but n minus 2, and this is nothing but n minus 2. And total will be n minus 2 into n minus 2 into n minus 2, or n minus 2 the whole cube, n minus 2 the whole cube. Here n is nothing but 5. So that implies 5 minus 2 the whole cube. 5 minus 2 is 3 cube, which is 27. So here our answer will be 27. If you just count if you count the number of cubes in this red cube, you will get 27. Instead of cutting, in the exam hall we will not be able to draw such clear figures and all. So we have to remember this formula, so that we can easily find the moment we see a question like this, we can easily find the answer. N minus 2 the whole cube as our answer, and we'll get our solution as n minus 2 is equal to 20. Sorry, the solution to question as 27. Sorry, solution to this question is 27. So I hope this is clear now, why this each side is n minus 2, and how this is the cubes that is needed. These are the cubes that will be surrounded by other cubes from each side. If you take any other cubes, that is cubes colored yellow, if you take this cube, it will be it will have cubes in this side and bottom side, but it won't be having cubes to this side and top side. So that is not surrounded by other cubes. So the only cubes that are surrounded are these red ones, and that is the number we found as 27. The solution to this question is 27. It is same as finding the number of cubes with no side painted. So if you check out the video, there is a video called cube dissection in the playlist. I have created a playlist with basic mathematics concepts, and in that playlist we have a video on cube dissection. It talks about finding different cubes with one side painted, two side painted, no side painted and all. The same concept we are using here. Instead of finding the cubes with no side painted, we are the question asked finding the number of cubes which are surrounded by other cubes. Same concept but different wordings. So once you understand the concept and understand that formulas involved, it will be very easy in the exam hall. You can solve the question within few seconds. So okay, so that is the solution to question 10a, 27. Next question, question 11. How many distinct 8-digit numbers can be found by rearranging the digits of the number 1, 1, 2, 2, 3, 3, 4, 4 such that odd digits occupy odd positions and even digits occupy even positions? So this is another question that uses the concept of permutation a lot. If you are unfamiliar with the concept of permutation, this question will be difficult. I advise, or I suggest you to check out the video on permutation and combination I have done in my playlist. So if you are new to this concept, if you are not aware of all the formulas that permutation and combination have, you can check that out. And I have discussed it in detail enough, discussed it in an enough manner to solve all the questions that appears in the CSAT. So you can check that out in case if you are not familiar with the concept of permutation and combination. So here we have 8-digit numbers. So, and it is said the odd digits occupy odd position and even digits occupy even position. So there are, as you can see, 2 odd digits, 1, 1, 3, 3, and 2 unique. So these are the 2, 2, 4, 4. These are the odd digits and these are the even digits. And we have 8 positions, right? 1, 2, 3, 4, 5, 6, 7, 8. So in these 8 positions, odd digits can occupy only at the odd positions. So effectively, we have only 4 positions to arrange odd digits, and we have only 4 positions to arrange even digits also. So, but there is a repetition also. So we have four odd digits and 4 positions, and 2 digits are repeating also. So we are going to use the concept, the special case of permutation with repetition. So we have 4 positions. Sorry, we have 4 positions. First we will arrange the odd digits and then arrange the even digits as a second step. So first arranging odd digits, we'll call this job 1. Arranging odd digits. We have 4 positions and 4 digits where 2 digits are repeating. So the formula for that is 4 factorial, since we have 4 positions. But since 2 digits are, if 4 were unique, if 4 digits were unique odd digits, then the total number of ways we can arrange 4 digits in 4 places will be 4 factorial. But since 2 digits are repeating, we have to multiply with, first we will take the first digit and see how many numbers, how many times it is repeating. So it is repeating 2 times. So we will have to divide it with 2 factorial. And we'll take the next digit and see how many times it is repeating. If it was repeating 3 times, we will use 3 factorial here. But since it is also repeating 2 times, we'll divide it with 2 factorial. So answer will be 4 factorial is 4 into 3 into 2 into 1. And 2 factorial is 2 into 1, which is 2 into 2. So just 4 cancels and the answer is 6. So we have 6 as our answer. If you are not familiar with this equation, if you are not familiar with factorial or this equation, please go and see the video I have done on permutation and combination, and it will be clear, I hope. So okay, and now our next J2 is arranging even digits. Arranging even digits, since even arranging even digits is also same. We have 4 digits, we have 4 places to arrange, and 2 digits is repeating, and 2 digits is repeating 2 times, exactly like the first case. So it will be same formula and our answer will be 6. Now J1 and J2, we can use the principle of multiplication here. So total ways we can do this will be 6 into 6, which is 36. So this is our answer. So in case why this multiplication, the total ways we can do J1 and J2 in succession will be 6 into 6. So why this is, if you are not understanding that also, just go and visit that video. You will get a better idea on how we got 36 as our answer. So this is the solution. 36 is the solution. Solution to question 11 is C, 36. Next question, question 12. A, B, C working independently can do a piece of work in 8, 16 and 12 days respectively. A alone works on Monday, B alone works on Tuesday, C alone works on Wednesday. A alone again works on Thursday, and so on. Consider the following statements. The work will be finished on Thursday. Second statement, the work will be finished in 10 days. Which of the above statement is or correct? So this is our question. So A completes a work in one day. A completes 1/8 of a work, and B completes a work on 1/16 in one day, and C completes in 1/12. So this is the information that is given, and it is given A works on Monday, B works on Tuesday, and C works on Wednesday. And again on Thursday, A works, Friday B works, Saturday C works, and that goes on like that. Um, so this is how they are working. And if you see, after 3 days, the total number of work that will be completed will be A's 1 by 8th work will be finished, B's 1/16th will be finished, and C's 1/12th will be finished. After 3 days, the work that got finished will be 1 by 8 plus 1 by 16 plus 1 by 12. So we have to sum this. So we have 8 is 4 into 2, so 16 is 4 into 4, and 12 is 4 into 3. We are going to use the LCM, concept of LCM. If you are not familiar with the concept of LCM, I have done a video on that too. You can check that out on the basic concept playlist. Okay, here our LCM will be 4 into 4 into 3. So here what is left will be 2 into 3, which is 6, plus, and here the only 3 plus and 4. Here it will be 4. Why? 4 into 4 into 3 will be 16 into 3. 16 into 3 is 16 into 3, 48. So 48. We get 48 here, and in the top we get 10 plus 3, 13 by 48. So in 3 days, when at the end of Wednesday, 13 by 48 works get completed. To complete this whole work, we should have 48 by 48, right? When we have 48 by 48 here, we can say that the whole work got completed, as it becomes 1. 1 by 8th work has to, if A was alone working for 8 days continuously, 1 by 8 into 8 will become 1, and the whole work will be completed. But A works only for 1 day, and then B picks up the work and then completes another 1 by 16th, then 1 by 12th, and in that manner, after 3 days, we will get 13 by 48th of the work completed. So as you can see, if we go like this, 13 by 48, and if you take this one whole thing as one group, we have 13 by 48 as the total work that gets completed after 3 days. So after 6 days, 13 by 48 into 2 will be completed. That will be 26 by 48. Still the work is pending. Still, so if you take 13 by after 3 days, so after 6 days and after 9 days, that is 1 2 3 4 5 6 7 8 9. After 9 days, how much work will be completed? 13 by 48 into 3 will be completed. That will be 39 by 48 will be completed. Still we have some work that is left to do. So after 9 days, we have 39 by 48 work. So we have 39 by 48 work got completed after 9 days. Okay. On the 10th day, we will be working 1, 2, 3, 4, 5, 6, 7, 8, 9. And after 10th day, A will be working again. So A will work for 1 by 8. If you see, the first question will be, second statement was the work will be finished in 10 days. So on the 10th day, A will be working. And if you see, 39 by 48 plus 1 by 8 is not equal to 1 or greater than 1. So it won't get completed, and we will have B working on the 11th day. On 11th day, B will work for 1 by 16. So if you add this up using the LCM concept, we have 39 plus we have 48, so 6 and 16, 3 by 48. So 39 plus 9 is 48 by 48. That is equal to 1. So the whole work gets completed after this is 9th day, and this is 10th day, and this is 11th day. On the 11th day, if you see, the whole work gets completed. 48 by 48 becomes 1. So the work will be finished in 10 days is wrong, and work will be finished on a Thursday. 11th day is which day? So we'll see Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, Monday, Tuesday, Wednesday, Thursday. So I'll just see once more. After 3 days it is Wednesday. Fourth day is again Thursday. Fifth day is Friday. Sixth day is Saturday. Seventh day is Sunday. Eighth day is Monday. Ninth day is Tuesday. 10th day is Wednesday. 11th day is Thursday. So the work will be finished on Thursday is correct. So since work is getting finished on the 11th day, Thursday is correct. Instead, if we don't want to just after you add 7, if you add just 7 to Monday, what happens? We will get B, right? Including Monday, it becomes A. If you count A also, but first day is, so I'll just check, since this could be on the 10, the work will be finished on a Thursday. So that is correct, right? The Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, Monday, Tuesday, Wednesday, Thursday. That is correct. So this statement is correct. The work will be finished on a Thursday. On the 11th day is a Thursday. So that is correct. So the solution to this question 12 is A only. 11th day is a Thursday. But it is work is getting finished on 11 days. So it is 10 days is wrong. It is 11 days. So that is why the second statement is wrong. This is true. I hope you understood. So this is very tricky question in the exam hall. There are a lot of ways we can mess up this question. One day if we just move, we will get another answer and we will find this statement as wrong, or it is getting so that's why I said in this exam every question looks very difficult and very tricky. So this was a very difficult exam, and yeah, anyway, I hope this is clear. I hope I have not made any mistake here, and this is the correct answer. If I have made any mistake here, do comment. So the solution to question 12 is A, 1 only. Next question, question 13. In this question, we have an operator like this. It's not addition. It is a different operator. So I'll just call this an operator, or simple, whichever way. So I'll call it a symbol, so that I can read the question and analyze what it is. So if 7 symbol, 9 symbol, 10 equal to 8, then 9 symbol, 11 symbol, 30 equal to 5, 11 symbol, 17 symbol, 21 equal to 13, what is the value of 23 symbol, 4 symbol, 15? So this operator does something different. We don't know what it is. It is definitely not addition. If you add this 7 plus 9 plus 10, we will get 26, and it is not addition then. So we have to decode what that is. So if you add 7 plus 9 plus 10, we are getting 26. We'll see whether there is any relation with addition here. And what is 9 plus 11 plus 30? We get 50. And 11 plus 17 plus 21 is nothing but 28, 49. So 49. So this is what we get in addition, and you see it is we can check whether these numbers are related to 8, 5, 13 in any manner. So here for 50 it is given 5. So 50 by 10 is 5, but 26 by 10 is 2.6. So that is not the case. So if you see the digits, look at the digits, 2 plus 6 is 8, and 5 plus 0, the digits of this answer, 5 plus 0 is 5, and 4 plus 9 is 13. So this operator means add the number and sum the digits. So even if you do it separately, we'll get 9 plus 7 is 16. So 6 plus 1 is 7. Now 7 plus 10 is 17. 7 plus 1 is 8. So even if you do it separately, we will get that answer. I guess. Let me just check. 11 plus 17 is 28. 8 plus 2 is 10. So 10 plus 21 is 10 plus 21 is 31. 3 plus 1 is 4. So that is wrong. So you cannot. So I think what this is kind of stupid question, I would say. Anyway, these three, if you, I think what they meant was just there will be three for this operation to work, and if you add all those three and if you sum the digits, you'll get the final one. So using the same logic here, 23 plus 4 plus 15. So 15 plus 4, 5 plus 4, 9 plus 3, 12, 1, 3, 5, 50. So sorry, 3, 5 plus 4, 9, 9 plus 3, 12, 1, 3, 4, 42. So 4 plus 2, 42 is the result we get on addition, and adding the two digits 4 plus 2 we get 6. So 6 is our answer. So solution to question 13 is A, 6. So I haven't seen a similar question before, but there's a good chance that an aspirant will get stuck in the exam hall. So if you are taking too much time to decipher the operator, what it means, like just skip the question and move on to the next. So this is what they meant. Personally, I felt this question is a little silly. Anyway, the solution to question 13 is A, 6. Next question, question 14. P, Q, R and S are distinct single digit positive numbers. Then what is the greatest value of P plus Q into R plus S? So it is given P, Q, R, S are distinct single digit positive numbers. Then greatest value is, like, we will assign P as 9 and PQ has to be distinct. So next greatest value Q can take is 8, and next bigger value R can take will be 7, plus S can take will be 6. This. So that is 17 into 7 plus 6, which is 13. So 17 into 13 is 2, 5, 7, 1, 1. 7 plus 5 is 12, 221. So D is the answer. Solution to question 14 is D, 221. So we just since the conditions was it has to be positive and unique, we just gave P, Q, R, S, T the maximum values possible. So the order doesn't matter. It will be this will be the largest number that we can get in this manner. So solution to question 14 is D, 221. Next question, question 15. A number n is formed by writing 9 for 99 times. What is the remainder if n is divided by 13? So we have a number 1, 2, 3, 4, 5, 6, 7 and goes like for 99 times, and we have to divide it with 13. So in such questions there will be some pattern in the here. UPSC doesn't frame questions that will have complicated formulas and all. So there will be some pattern when we manually do this. So we will do that. So if there was only one 9, the remainder, if there is only one 9, the remainder would have been 9. So if we take two 9s, or 7 into 3 is 13 into 7. We'll do 13 into 7 is 21, 2, 7, 91. So we have 91 here, 7, and remainder would have been 8. So for 2 nines, so for 1 9, if it was just 1 9, we would have remainder as 9. 9 as our remainder for 1 9. So I'll just for 1 9, our remainder would have been 9, and for 2 nines, our remainder would have been 8. Okay, we'll see as we proceed. So we'll bring in 1 9 to down to here, so we have 89. So 13 into 6, 6 into 3, 18, 678. So we'll have 6 here and 78. So we have 11 as our remainder. So in case we had 3 9, we'll get 11 as our remainder. So 3 nines, we get 11 as our remainder. Now we will bring one more 9 down. So 9. So 13 into 7 is okay, 13 into 8, 8 into 3, 24, 2, 10. 13 into 8, right? 8 into 3, 24, 2, 10, 104. And 13 into 9, 9, 3, 27, 2, 9, 11, 117. So we would have 117 here, 9, and our remainder would have been 2. So 2 for 4 nines. So if we had only 4 nines, our remainder would have been 2. So we'll bring one more 9 down, 29. So 13 into 2 is 26. So 2, 26. So we have 3. So in case we had 5 9, our remainder would have been 3. And if you bring down 9, one more 9, it is 6th 9. We are bringing down 6th 9. So 39, 13 into 3 is 39. So here the remainder becomes 0. So if we had 6 9, our remainder would become 0. Now if you can see, if you bring down one more 9, we'll have 9 as our remainder. That is 7th 9 onwards, we'll have remainders repeating. 9, that is just, I'll just show. We bring down 9, one more 9 down. What happens? Sorry. If we bring one more down, we have to put 0 here. So our remainder will be 9 only, and we will have to bring one more 9 down. So 99. So this is same as 9. Now again repeats 7. 99, 7 becomes 91, and we get 8. Again 89. So the same process repeats. So 7, 6, 9, 2, 3, 0. It repeats. This part repeats. So so our remainder will be 9, 8, 11, 2, 3. That repetition happens. So the question asks for 99 times. So for that we have to just divide, find the closest number that it is divisible by 6. So we know 90 is divisible by 6, and 96 will be divisible by 6. So if we had only 96 9, our remainder would be 0. And if we had 97 9, our remainder will be 9. 98 9, our remainder will be 8. And 99 9, our remainder will be 11. So 11 is the answer. So our solution to question 15 is A, 11. So this is the pattern here. The remainders repeat, and we just have to figure out what is the remainder at 99 when 9 repeats for 99 times. The solution here is 11. A, 11. Next question, question 16. Let x be a positive integer such that 7x plus 96 is divisible by x. How many values of x are possible? So if 7x plus 96 is divisible by x, that means it will be of the form kx. K be any positive integer. So it will be of this form. So if you rearrange, we have, since 7x plus 96 is equal to k will be greater than 7. Okay. Otherwise otherwise x has to be negative. Since it is given x is a positive integer. So if you rearrange, we have x into k minus 7 as 96. So this is the condition that is given. So the smallest value k can take from this equation is, since x is a positive integer, the smallest value k can take is k equal to 8, greater than 8, greater than or equal to 8. This is the smallest value. So when k equal to 8, x will be 96. So the largest value x can take will be 96. So for all other values, we will be able to find k such that if x is divisible by 96, we can find a value for k such that this equation will be satisfied. So from if you see, 96 is nothing but if you divide by 3, we get 32 into 3, or 32 is nothing but 8 into 4 into 3. So this whole 96 is 8 into 4 into 3. Or if you again split, we get 1 into, as product of prime numbers, we get 8 is 2 into 2 into 2, 4 is again 2 into 2 into 3. So the possible values of x here is x is equal to 1. If x is equal to 1, k minus 7 has to be 96. For that, k minus 7 is equal to 96 means k is equal to 96 plus 7, which is 103. So sorry, k minus 7 is equal to 96 means 96 plus, sorry, k minus 7 equal to 96. So 96 plus 7, yeah, 103. So for k equal to 103 and x is equal to 1, this equation satisfies. So for any value greater than x also, we can find k such that this equation satisfies. So x is equal to 1, 2, 3 are the possible values for x. Then we can pick up any combinations, like x is equal to 4, we can 2 into 2 we can take. So 4 we can take, if you take 8 we can take, 16 we can take, 32 we can take. So 2, 4, 8, 16, 32 we can take. Yeah. Now we will see the combinations. 4 into 3, 12 we can have value for 4 into 3, and 8 into 3, 24 we can have. So that is, if x is equal to 24, what happens? We are taking 8 into 3, right? So 8, 2, 4, 8, 8 into 3. X is equal to this. So k has to be this. K has to be, k minus 7 has to be 2 into 4, 4. So when x is equal to 24, k minus 7 has to be 2 into 4, 4. So, or k equal to 7 plus 4, which is 11. So we will be able to find k equal to 11 as, and we will be able to satisfy this equation. So 24 can be one case. Any combination we take, we will be able to find k, and this equation will satisfy. So 8 into 4, 16 into 3 will be 16 into 3 is, so, and we already said the maximum value x can take will be 96. Since any value above 96 means k minus 7 has to be a fraction or a negative number. So sorry, k minus 7 has to be a fraction for this equation to get satisfied. So up to 96 x can have values. So 16 into 3, so 6 into 3, 18, 1, 48. 48 is a value we can have, and 32 into 3 is 96. So now up to 96 we can have. So these are the possible combinations. If you see the total number of, so we have wrote all the combinations, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, So did we miss out anything? 1 can we answer, 2 can we answer, 3 can we, 4 into 2 8, 8 into 2 16, 16 into 2 32, 3 into 2. Okay, 3 into 2 is a possible combination. 2 so 3 into 2 is also a possible combination. So 3 into 2 is 6. So 6, 12, 24, 48, 96 are combination that have 3. So these are just product of multiples of 2. So 1, 2, 3, 4, 5, 8, 6. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we got 12 combination. These are the 12 possibilities of x. So our solution will be question 16, 12. C, 12. These are the possible combinations. Basically, we took all the possible combination out of this 1 into 2 into 2 into 2. So these are just different combinations, splitting this 2 into 2 groups. So this is the logic. So these are the possible combinations. So this is the solution to question 16. C is the answer. Next question, question 17. Each digit of a 9-digit number is 1. It is multiplied by itself. What is the sum of the digits of the resulting number? So the question asks, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9 into 1, 2, 3, 4, 5, 6, 7, 8, 9. So we are multiplying these two and we will get a result, and we have to sum the digits of the result. So instead of multiplying all this, we definitely there is a pattern here. So we will first take 3 ones and see what is the pattern. So if you multiply these 3 ones, what we get? 1, 2, 3, 2, 1. So if you take 3 ones, we have 1, 2, 3, 2, 1. So that means 4 ones. If you take that means if you take 4 ones, what will you get? 1, 2, 3, 4, 3, 2, 1. So similarly, if you take 9 ones just like this, we will get our answer as 1, 2, 3, 4, 5, 6, 7, 8, 9, 8, 7, 6, 5, 4, 3, 2, 1. This will be the answer if you take the product of this. Up to 1, 9 digits, then 8, 7, 6, 5, 4, 3, 2, 1. 1, 2, 3, 2, 1. 1, 2, 3, 4, 3, 2, 1. Similarly, 1, 2, 3, 4, 5, 6, 7, 8, 9, 8, 7, 6, 5, 4, 3, 2, 1. So this will be the result. Now we just have to add all the sum. We don't have to manually add all the sum. We'll take, if you see, this is just two symmetric parts. We have to 1 to 8 sum into 2, since it is happening 2 times, plus 9. So what is the sum of 1 to 8? We have a formula. This is a sequence. We have a formula, a plus last number, which is say last number into n by 2. So here this will becomes 1 plus 8. So 1 to 8, if you take sum, 8 by 2, or 9 into 4, 36. So sum of 1 to 8 is 36, and then we have a 9, and sum of 1 to 8 again, sum 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8, which is 36. That is what we found out using this formula. So 36 plus 36 plus 9, 36 plus 36 plus 9. So 6 plus 6, 12, 12 plus 9 is 21, 2, 6 plus 2, 81. So our solution will be C, 81. So solution to question 17 is C, 81. Next question, question 18. What is the sum of all digits which appear in all the integers from 10 to 100? So 10 to 100, our number is from 10 to 100. So we will split it into different groups and add all the digits. So for that we will 0 to 9. Sum of digits from 0 to 9 will be what? 0 plus using the formula first number plus last number. Whenever we have a sequence, we can use the formula. So we are 2, 3, 4, 5 up to 9. So if you want to sum all the digits, we'll get what? First number plus last number into n by 2. This is the formula we are going to use throughout this question. So first number is 0 to 9. If you sum all the digits, what we have? 0 plus 9 and total 10 digits into 10 by 2. So 5, 9 into 5, 45. So 45 is the sum of all digits from 0 to 9. So now we will split our numbers into different groups. So 10 to 100 we will write as two groups, 10 to 19, then 20 to 29. Similarly, we have 90 to 99. We split into 9 groups. Okay. And what is the sum of all the digits from 10 to 19? So here unit place has 0 from 0 to 9. So if we split all the digits in the unit place and tens place separately, we have in tens place each number has 1. So 1 into 9, there are 9 numbers. So adding all the digits, that is 10, 11, 12 up to 19, right? So if you add all the digits in the tens place, we have 9 ones. So here 9 into 1 plus 0, 1, 2, 3 up to 9, which we already found out the sum as 45. So 45. So 45 plus including 10. So there are 10 numbers. So 9, not 9 into 1, 10 into 1. So 10 into 1 or 10 plus 45. Similarly, if you take all the digits from 20 to 29, we have 21. Similarly, if you add all the digits, we have 10 times 2 plus 45 is same. So unit place, when you add all the digits, we get 45 itself. So again there is a pattern appearing. Similarly till 90. So 9, when you add the digits of this numbers, all the tens place, 9 into 10 gives 90 plus 45. This is the total sum. So if you add 10 plus 45, 20 plus 45, 90 plus 45 and all the sums, we will get the total sum required. So what is this? So 45 is appearing 9 times. So 45 into 9. So 9 into 5, 45. 9 into 4, 36, 40. So 405. So if you add all 45s, we get 405 here. And now we have to add 10, 20, 30. So we have a sequence again here, 10, 20, 30 up to 90. This 30. So what is the sum of all these numbers? So first number 10 plus last number 90. Total numbers will be 10 again. 10 by it's not 10. There are totally 9 numbers, right? 10 to 90, if you take 9 numbers, 9 by 2. So 100 into 9 by 2. So 50. So 9 into 50 is 450. So if you add all this, we get 450. So 450 plus 405, that is 450, 855. So we get 855 as sum. What is the sum of all digits which appear in all the integers from 10 to 100? So we didn't include 100 here. So we from 10 to 99 only we calculated. Now plus we have to add the digits of 100. So 100, if you add, there is only just 1. So plus 1, we get 856 as our answer. So this from 10 to 100 means including 10 and including 100. So 10 was included here, but 100 was not included. So we added just 1 to it. 100 has, when adding the sum digits of 100 means 1 plus 0 plus 0, which is just 1. So adding 1 to 855, we get 856 as our answer. So solution to question 18 is B, 856. Next question, question 19. ABCD is a square, 1 point on each of AB and CD, and 2 distinct points on each of BC and DA are chosen. How many distinct triangles can be drawn using any 3 points as vertices out of these 6 points? So we'll just show what is given. So we have a square and ABCD, and it is said there is 1 point on each of AB and CD. So there is 1 point like this on AB and CD, and 2 distinct points on each of BC and AD. So BC and AD, we have two distinct points. Okay. How many distinct triangles can be drawn using any 3 points as vertices out of these 6 points? So if you look at the figure, no matter how you choose 3 points, you can form a triangle. So there are no 3 points on a single line. If that was the case, then choosing those 3 points would not give us a triangle. But since only 2 points are at the maximum in one line, we can choose randomly any 3 points and we will get a triangle. So total number of ways we can form triangle will be the total number of ways we can choose 3 points from this 6 points. 3, 4, 5, 6 points. So which is a classic case of combination. So 6C3 is the answer. So if you don't know combination and this formula, just please go and see the video that I have made on permutation and combination. You can find that video in the playlist Basic Concepts of Mathematics, and revisit this question after going through that video. Then it will be more clear. So here it is 6C3. So 6C3 is 6 into 5 into 4 by 3 into 2 into 1. So 3 into 2 is 6, 5 into 4 is 20. So total 20. In 20 ways you can select 3 points, and in 20 ways you can form the triangles. So solution to question 19 is C20. Next question, question 20. A box contains 14 black balls, 20 blue balls, 26 green balls, 28 yellow balls, and 38 red balls, and 54 white balls. Consider the following statement. Okay, so before reading the entire question, let me just note down what is given. So 14 black and 20 blue and 26 green, 28 yellow, 38 red, 54 white. These are the number of balls. And the question, consider the following statement. First statement is the smallest number n such that any n balls drawn from the box randomly must contain one full group of at least one color is 175. Okay, we'll decode that part. Second statement is the smallest number m such that any m balls drawn from the box randomly must contain at least one ball of each color is 167. Which of the above statement is or are correct? So we will take up the first question. The smallest number n such that any n balls drawn from the box randomly. So we are randomly selecting balls from the group, from this group, and our minimum. So what is the minimum n that we must randomly choose, so that it must contain one full group of at least one color. So one full group of at least one color. So this is the requirement. So in such questions, we have to think about the worst case scenario and see what is the minimum number that will come in such a scenario. What is the minimum number that we have to pick in such a worst case scenario? So so that will give the minimum number, the smallest number, such that randomly if you choose, that will ensure that this condition will be satisfied. We'll see how. So since we need one full group of at least one color, so we'll think about the worst case scenario. Worst case scenario is like we randomly start picking the colors and we get say 53 white balls. So I will just explain how that is a worst case scenario. So it is 53 white balls we get, and say if we get, okay, so more clarity, you will have more clarity if you start from the smallest group. So I start to randomly pick up the balls and I get first 13 black balls, say. 13 black balls. So if we take when we take the 14th ball, if it is a black, then we will have one full group of at least one color. That is the best case scenario. So we won't get, so we are talking about the worst case scenario. So what is the worst case scenario? Instead of getting the 14th black ball, we start picking up the blue ball, say. So we started getting blue balls and we get 19 blue balls. So first we got 13 black, then we get 19 blue balls. So if we get one more blue or black, then our criterion will be satisfied. But instead of when we continue randomly picking, instead getting in the one black and one blue, we start getting green balls and we get 25 green balls. And the one ball that is needed to complete this group also we are not getting. Then we start getting yellow balls and we get 27 yellow balls. Then we start getting 37 red balls and we are getting 53 white balls. So this much balls we picked up and still we are not getting one full group. So we didn't get one full group. So now we have one black left, one blue left, one green left, one yellow left, one red left, and one white left. So if we pick one more balls, we can say that if we pick one more ball, we will definitely get one full group of at least one color. We are not sure which color that is, but if we pick this much balls, we consider our worst case scenario, and when we pick up one more ball, we will for sure get one full group of at least one color. So this is the number that we needed. Now we just have to sum everything. So if you see 7 plus 7, 14, 14 plus we are just summing. So 7 plus 3, 10, 10 plus 1, 11, 11 plus 7, 18, 18 plus 5, 23, 23 plus 3, 26, 26 plus 9, 23, 26, so 29 is 35, right? So 3. Let me just confirm that. 10, 11, 18, 18 plus 5, 22, 22 plus 9, 40, 10, 11, 18, 18, 23, 23 plus 9 is 23, 26, 26 plus 9, 26 plus 9 is 35, correct. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 12 plus 5, 17, so 175. So 175, if we pick up 175 balls, we can say that we will get one full group of at least one color. So the statement, the smallest number n such that any n balls drawn from the box randomly must contain one full group of at least one color is 175 is correct. So this statement is correct. We get the number as 175. This is how we get our number as 175. That is, we think the worst case scenario, and in that scenario, what is the maximum number we have to pick? Sorry, the minimum number that we can pick to ensure at least one color. In this worst case scenario, saying 176 is the number doesn't make sense. So sorry, in the worst case scenario, by picking just 175, we will get one full group of at least one color for sure. So we got our first answer. Now we'll see what is our second statement. The smallest number m such that any m balls drawn from the box randomly must contain at least one ball of each color is 167. 1 second, let me just so here the question asks, our requirement is contain at least one ball of each color. We need at least one ball of each color. So one ball of each color. So what is that criterion? At least one ball of each color. So we need one black, one blue, one green, one yellow, one red, one white. So in that scenario, what is the worst case scenario? We need to get to get one ball of each color means say we get the the color which have the smallest number, the last. If we keep getting 54, 38, 20, 28 and all these but not black, which is the smallest number, we will have to pick up so many balls before getting black. That is our worst case scenario. I will explain how. So first we start picking up the balls, and now we are getting first 54 white balls. So we need at least one ball of each color. So getting 54 white balls is a worst case scenario for us. Now we continue picking up, then we get 38 red balls. So 38 red balls, we get one white ball and one red ball. All other ball was useless for us. So that's how this becomes the worst case scenario. So and then we start picking, then we get all the yellow balls 28, then we got all the green balls 26, and we get all the blue balls 20 blue balls. Now since we got all these balls, one more ball we can, if we get one more ball, we can say that we will have the ball of each color. So we will ensure that we are getting a ball of even in this worst case scenario, this is the minimum number that we have to pick to get the one ball of each color. So this is the this much balls we have to pick in that worst case scenario. So if you add all this, 8 plus 8 16, 16 plus 4 20, 20 plus 6 26, 26 plus 1 27, 2. So 5 plus 2 7, 7 plus 3 10, 10 plus 2 12, 12 14 16. So 167. So we get our number as 167. So this is the worst case scenario, and this is the minimum number that we are picking up in that worst case scenario. And picking up 167 balls will ensure that we will have one ball of each color even in that worst case scenario. So since we are picking up the balls randomly, we have to always consider the worst case scenario rather than the best case scenario. If we just think about the best case scenario, we are not thinking randomly. We are not picking up the balls randomly. That means it does not include the worst case scenario. Sorry. So whenever we are picking up the balls randomly, we have to think about the worst case scenario, and in that scenario, what is the minimum number that we have to pick? That is what we should be thinking. So in the second case, our solution is 167. So it is given 167. So even the second statement is correct. So which of the above statement is correct? The solution is C, both 1 and 2. So solution to question 20 is C, both 1 and 2. Next question, question 21. If 0 is written as CHUR, then how is player written? So if you see CZERO, 4 letters, is converted to CHUR. So so what they are doing is moving 3 alphabets in a cyclic manner. So we have A, B, C up to Z. Then we have again it again starts with A, B, C. So in that case, it's a circular repetition. In this case, if we move each alphabets 1, 2, 3 into third alphabet, we will get this. So Z, next alphabet will be one shift will be A, second shift will be B, third shift will be C. So Z plus 3 is equal to C. So similarly, if you check E plus 3 is what? F, G, H. So equal to H. So that is the shift they are doing. R plus 3 is U, and O plus 3 is M, N, and M, L, M, N, O, P, Q, and R. So R. So similarly, if you shift each, P will be shifted to Q, R, S. So every alphabet is starting with S. If you check R will be shifted to S, T, U, U. So U. So the only answer that is ending with U is D. So we can, without checking, we can say D is the correct answer. So you can check also, L will be shifted to O, and A will be B, C, D. It will be shifted to D, and Y will be shifted to Z, A, B. So B, and E will be shifted to F, G, H, H. So plus 3 is the shift they are doing. So D is the correct answer. Solution to question 21 is D. Next question, question 22. Consider the following statement. A is older than B. So I'm going to note down the points as I read. First statement is A is older than B, which can be written as A is greater than B. C and D are of the same age, so C equal to D. E is the youngest, so E is youngest. F is younger than D. F is younger than D. F is older than A. How many statements given above is required to determine the oldest? Okay, there is some mistake here. Determine the oldest person or persons. So that's the question. So our potential candidates are A, B, C, D, E, F, E, F. So from using this statement, A is greater than B, we know that B is not the oldest. So we will strike off and we will use first statement. Now we have this much people. Now we can use this statement to find that A is not the oldest person here. So we can strike off A. So these are the people left. Any of these people can be old. So if you see, only one statement has E in it. So we can use that to make sure that E is not the oldest. So it is given E is youngest, so E is also not oldest. Now C, D or F can be old. So if you see F is less than D, it is given F is less than D. So from this statement we know that D is the older among F and D. So we can use that. So we can use that to eliminate F as the option. Now we are left with C and D. Either C or D can be older. So we will have to use this statement to find exactly, fifth statement, to exactly know that C and D are same. C is equal to D. That is, among all these people, C and D are the oldest, are the oldest people, and they are equally old. So it is asking oldest person or persons. So persons. So here C and D are the oldest persons. So we will have to use all the 5 statements to get to this point. So our answer will be D, all 5. So solution to question 22 is D, all 5. Next question, question 23. Consider the following, including the questions and statements. There are 5 members A, B, C, D, E in a family. Question is, what is the relation of E to B? So they are asking relation between E and B. Statement 1. So 4 statements are given. Which one of the following is correct in respect of the above question and statements? So statement 1, statement 2, statement 3 are sufficient to answer the question. Statement 1, 3 and 4 are sufficient to answer the question. All 4 statements together sufficient to answer the question. All 4 statements are not sufficient to answer the question. That is the option. So we'll check the statements. So A and B are married couple. So I am going to use the notation like this. A and B are married couples. Okay, wait 1 second. So I'll just write B equal to A. D is the father of C. So it is given D is the father of C. So we have a D here, and so we know that D is the father, so D is a male person. So I am going to use the square symbol for male people, and C we don't know the gender of C. Okay, E is D's son. So in statement we used statement 1. This is statement 1. I will just mark statement 1. This is statement 2. This relationship is statement 2. and E is D's son. So again we have another statement. E is D's son. E, we have E is D's son, and A and C are sisters. So this is statement 3, and now it is given A and C are sisters. So A is a female person, so I'm going to circle it. And since A and C are sisters, D is the A C's father is D, so we can get that. So this is the point where we were able to connect A to E, C, and all. So fourth statement is one that connected these two, and to get a relationship between B and E, so we now know the relationship between B and E, but for that we need what all statements. First statement is needed to connect B to A, so statement 1 is needed. Statement 2, D is the father of C, so to connect A and C, since we need two statements. So since we are since E's relationship comes like this, so A and C has to be connected and connected to D. So statement E is D's son is also used, D is the father of C is also used, and A and C are sisters are also used. Only by using all these statements we will be able to link B and E. So since A and C has to be connected, E and D has to be connected, so that B and E will be linked. So all the four statements are used here to make the connection between E and B. So all four statements together sufficient to answer the question is the answer here. So solution to question 23 is E. All four statements are needed to answer the question. Next question, question 24. Choose the group which is different from the others. If you look at the numbers 17, 37, 47, 97, 31, 41, 53, 67. First thing you will notice is this: every number is odd number, and these numbers, there are some numbers that are very common, they are very familiar to us, which are prime numbers. 17, 31, 71 are all prime numbers. So odd numbers and prime numbers. So from that itself, if you check 37, 47, 97, all are prime numbers. 41 is a prime number. So 53, 7. Okay, here 91 is, so if you see 91 is divisible by 7. 70 plus 21, 91, so it is divisible by 7. So this is not a prime number. So group which is different from the others, if you look at this, this is not a prime number. So probably so this is a group that is different from others. It has one non-prime number. So this is a very difficult question. If you should know a lot of prime numbers, and you should be familiar with a lot of prime numbers, and it is not easy to quickly conclude that this is a question that wants us to look for non-prime numbers. So yeah, anyway, this is as I said, the only way to solve such questions is do as much problems, get familiar with prime numbers, squares, cubes, and all such numbers, so that we can quickly identify some patterns in the exam. I wouldn't be surprised if I find myself skipping this question in the exam also. So yeah, there will be some difficult questions in the exams. This is one I would say. Yeah. So solution to question 24 is D. The only all other numbers are prime numbers. D has one non-prime number in it. Okay. Next question, question 25. What is the sum of all 4-digit numbers less than 2000 formed by the digits 1, 2, 3 and 4 where none of the digit is repeated? So we have 4 digits 1, 2, 3, 4 and 4 places to fill in the in forming the 4-digit number less than 2000. So if the number is less than 2000 and the digit is 4, the only possibility for this place is to be have 1. So if it has 2, 3 or 4, it will be greater than 2000. So this place is fixed. Now we have 2, 3 and 4 left to fill these 3 spaces, and we will have 1, 2, 3, 3 factorial combinations. If we just shuffle 2, 3, 4 in all these places, we will have three numbers to shuffle between 3 places. So we will have 3 factorial, that is 6 combinations. So if you look at all those combinations, you can see 4 will appear 2 times here, 3 will appear 2 times here, 2 will appear 2 times here. So these are the 6 combinations. Similarly, we will have 4 appearing 2 times here, 3 appearing 2 appearing 2 times, not in this order but in a shuffle manner. 4 will appear 2 times here, 3 will appear 2 times here, 2 will appear 2 times here. Same goes here also. So if you add all this, we have 4 into so 4 plus 4, 8, 8 plus 6, 3 plus 3, 6, 8 plus 6 is 14 plus 4. So 14 plus 4 is 19. So we will have 9 here. So let me just check. 4, 8, 11, 14, 16, 18. Sorry, this is 18 here. I don't know where I made. This is 18. So here 1. There will be 18 plus 1, 19 here. So 1. So again 18 plus 1, 19 here. So 1. So all these 6 places will have 1. So 1 plus 1 plus 1 plus 1 plus 1, 6 plus a carryover 1. So 7. So our answer will be 7998. So option A, 7998 is the answer to solution to question 25. So I'll just explain once more. So I'll how I said, so the one first place is fixed, then we will have 2, 3, 4, and say fixing 2 we will have 2, 4, 3, and then again 3, 1, 3, 2, 4, again fixing 3 we will have 1, 3, 4, 2, again 4, 2, 3, 1, 4, 3, 2. So if you see 2 4s, 2 3s, 2 2s. Similarly, 2 4s, 2 2s, 2 3s. Same goes here also. That's why I wrote it like that. So in this case, we'll get 7998 as our answer if you just add. These are the 4-digit numbers that we can make out of 1, 2, 3, 4, and if no other digits are repeating. So yeah. So solution to question 25 is A, 7998. Next question, question 26. A principal P becomes Q in 1 year when compounded half yearly with R percentage annual rate of interest. If the same principal P becomes Q in 1 year when compounded annually with S percentage annual rate of interest, then which one of the following is correct? Options are R equal to S, R greater than S, R less than S, R less than equal to S. Sorry. So if you're familiar with the concept of compound interest, you can right away see the first compounding half yearly is better for us, and in even if after compounding annually we are also getting the same interest, that means S has to be greater than R. So if you're familiar with the concept, you can right away say S is greater than R, and the solution to question 26 is C. So I'll just explain with an example. Say we have 100 rupees, and our what happens when we compound half yearly? Say annual rate of interest is say 20%. Okay, so 20% means half yearly we will have 10%. So 10% of 100 because 10% of 100 is 10 rupees. So when after 6 months, this 10 rupees interest will be added to the principal. So after 6 months, we will have 110 rupees. Now, when 1 year gets completed, we will add 10% of this to our interest. So 10% of this is 11. So 110 plus 11, which is 121 rupees. So at the end of 1 year, we will have 121 rupees. So let's say instead of doing this, we just compound annually with 20% interest. So we have 100 rupees. 20% will be 20% of 100 will be 20 rupees. So at the end of the year, we will add 20 rupees to it and 120. So if you compound half yearly, we will get 121, and if you just compound annually, we will get 120 rupees. So as you can see, if you compound half yearly, we are getting better interest, and that is why I said for these to match, if in the question it is said we have different annual interest rate and for the annual case and half yearly case. So if this has to match this interest rate, the interest rate in this case has to be higher. Otherwise, this won't match. Otherwise, this will be always higher. So for these values to match, this interest rate has to be higher. So that means S percentage has to be higher than R percentage, which is the half yearly case. I hope you understood what it means to compound half yearly with an R percentage interest rate, and what it means to compound annually with a percentage interest rate. These two are the different case I explained. So even if you have still doubt regarding this concept, do comment. I will try to address it. So anyway, solution to question 26 is C, R is less than S. Next question, question 27. How many natural numbers are there which gives a remainder of 31 when 1186 is divided by these natural numbers? So 1186 divided by a natural number gives remainder 31 means if our natural number is P, it will be of the form Pk plus 31, where K is K is any positive integer. So K is any positive integer, our natural number has to satisfy this equation. So that is what it is given. So that means P into K will be of the form 1186 minus 31, which is 1155. So our natural number into a positive integer should give 1155. So we can factorize this. To see what are the possible combination P will have. So if you divide it with 11, if you can see clearly it divides with 11. So 1, 11, 5, 0, 55, 5, 55, 0. So 11 into 105. 11 into 105 again goes with 5, 21. So 11 into 5 into 21. 21 is nothing but 7 into 3. So I have factorized this number into this group. So now we can clearly think of different combinations of P that we can make out of this. So the only for this to satisfy P cannot have P should be greater than 31, right? P has to be greater than 31. That is the only condition we have. When we make P out of this, we cannot say P equal to 11 and K equal to 5 into 7 into 3. So if you say, so since P into K is if P is 11, K has to be 5 into 7 into 3. But this cannot be the case because in that case we will not have the remainder 31. P has to be greater than 31. That is the only condition we have. So we will make different P from this. It is just a matter of grouping. So one example would be if you group like this, this could be P and this could be K. So P into K will be this number and P is 55. So when I say P is equal to 55, what do I mean? Like if I take 1186 and divide it with 55, K will be 7 into 3, 21, right? So 210, 8, 86. So 21, 55. We will get the remainder 31. So 55 into 21 is 155 and we will get the remainder 31. So that is what it means. P can be 111 into 5 and 73. So now, if you say, as I said, if you pick just one number, P could be 11, 5, 7 or 3. All these are not possible since P has to be greater than 31. Now we have 11 into 5 into 73. We can pick any two number just like I did now, 11 into 5. We can pick any two number and we can use combination. Out of 4 numbers, selecting any two number will be 4C2 or 4 into 3, 2 into 1. So 3 into 2, 6. We will have 6 combination. We have 6 combination out of picking any two will give 6 combination. But if you notice, 5 into 3 is 15. That is less than 31. And 7 into 3 is 21. That is also less than 31. If you pick any two combinations, two of them will be less than 31. So that has to be removed. So 6 minus 2, 4. So picking 2 will give us 4 valid cases for 4 valid values for P. Which are those values? We'll just see. Since there is only 4 values, we can easily make out. 11 into 5, 55. 11 into 7, 11 into 3. These are the 3 ones. Then we can take 7 into 5 also. These are the 4 possible value we got here. So similarly, if you want to select 3, we will get 4C3, or 4C3 is nothing but 4C1, which is 4 into just 4 and 3 into 2 by 3 into 2. We get 4 valid cases. So we will get 4 valid cases when we pick 3 out. Which are the 11 into 5 into 7. 11 into 5 into 7. 11 into 5 into 3 and 5 into 7 into 3 and 11 into 7 into 3. So these are the 4 cases that we can pick from 4C3. These are the 4 cases. So we get 4, and now we have one more case, that is picking all the numbers. So P could be 11 into 5 into 7 into 3 also. So we have one case here. So total 4 cases and 1 cases. 4 plus 1, we have 9 cases. So if you are confused, I will just note down all the numbers, all the combinations we just found out, which is 11 into 5, 11 into 7, 11 into 3, 7 into 5, and 11 into 5 into 7, 11 into 5 into 3, 5 into 7 into 3, 11 into 7 into 3, and 11 into 5 into 7 into 3. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So total 9 possibilities are there for P, which will give remainder as 31 if you divide it with the 1186. So solution to question 27 is D, 9. So I hope this is clear. You don't have to know the combinations and all. If you know that, you don't have to list out every possible combination. You can easily use the formula to find the total combinations. Even if you don't know that, you can write out all the combinations and find the answer. So if you want to learn if you are interested to know, if you are not familiar with the concept of combination and permutation, and if you want to learn, please check out the video on the permutation combination I have done. You can find that in the basic mathematics concept playlist in my channel. Okay, so solution to question 27 is D, 9. Next question, question 28. Let PP, QQ and RR be two-digit numbers where P is less than Q is less than R. If PP plus QQ plus RR equal to TT0, where TT0 is a three-digit number ending with 0, consider the following statements. The number of possible values of P is 5. The number of possible values of Q is 6. Which of the above statement is or are correct? That is a question. So I'll just note down the given information. So it is given PP plus QQ plus RR equal to TT0. And it is given P is less than Q is less than R. So this is the conditions given. And question asks, what is the, since it is set PP, QQ, R are two-digit numbers, P, Q, R cannot be 0. That is also there. And the number of number of possible value of P and Q R is the one we have to find out. So we will see from this, as you can see, P, Q, R cannot be 0. Then the only combinations P plus Q plus R can be either 10 or 20. So since P less than Q less than R, the highest value R can take is 9. So since 8, 7, the highest value P plus Q plus R can take is 9 plus 8 plus 7, which is 9 plus 8 is 17. 17 plus 7 is 25. So P plus Q plus R is less than 25 also. So it cannot be 30. P plus Q plus R equal to 30 is not possible. So it can be either 10 or 20. So since we are looking for the maximum possibilities, we don't have to consider P plus Q plus R equal to 10 case, because that will be included in the P plus Q plus R equal to 20 scenario. So the smaller values will be included in the larger sum. So we just need to consider P plus Q plus R equal to 20 situation. So we'll see, we'll just assume P plus Q plus R equal to 20. So that means T will be what? P plus, it is given P plus Q plus R equal plus 2 carry over. It's 220, so plus 2 equal to TT. So or T equal to 22, so T equal to 2. So if you put 20 here, 20 plus 2, 22, TT is 22 and T equal to 2. We also have that. We are going to explore this situation where P plus Q R equal to 20. So this is one condition we have to satisfy. So what are the possible values of P? P can have 1, 2, 3, 4 and 5. Why? Because if what we have to check is even when P takes 5, Q should be greater than 5, right? So minimum value we can take 6. Minimum possible value for R will be then 7. So 5 plus 6 plus 7 is 6 plus 5, 11 plus 7, 18. So this is possible. But if you assume P is 6, what happens? If P is 6, the smallest value Q can take satisfying this will be 7. And R smallest value will be 8. So 7 plus 6 plus 8 will be 7 plus 6 is 13 plus 8 is 21. Right? Yeah. So that is greater than 20. Is greater than 20. So we cannot find any combinations, valid combinations for PQR that satisfies to be 20. Even the smallest combination when P equal to 6 will be greater than 20. So we will not be able to pick P equal to 6 to satisfy this condition. So here, as I said, P should be less than 5. So when I say P can be 5, what I mean, when P equal to 5, say we pick Q equal to 6. So and 6 plus 5 is 11. It has to be, sum has to be 20. So 6 plus 5, 11 plus 9. R be 9. So 5, 6, 9. 5 is less than 6 is less than 9. And the sum is 20. So that is a combination, a possible combination is there. So we can find some possible combinations or we could also write 5 plus 7 plus 8 also. That is also a valid combination. So where P is less than Q is less than R. So these two possible combination is there for P equal to 5. For P equal to 6, as I showed earlier, there are no valid combination where P plus Q plus R equal to 20. So these are the possible values of P that we can find for P plus Q plus R equal to 20. So there are 5 such values. The number of possible value of P is 5 is correct. Now we will look what is the number of possible values of Q is equal to Q is 6. So for Q equal to 6, we should see when P equal to 1, we'll take the case where P equal to 1 as the P equal to P be the smallest number to have Q, for Q to have the highest possible combinations. So P equal to 1, let's take. So 1 plus what all values Q can have. Q can have P, the smallest value P can have is 1, but Q should be greater than P. So from Q can start from 2. Q can be 2, 3, 4, 5, 6. Can it be 7? Let's say 1, 7. So R has to be greater than 7. So 8. So 7 plus 1, 8. 8 plus, yeah, that is possible. So Q can be 7. So 8. Okay, there is another problem. So we don't have to find P doesn't have to be 1. P can have higher values also. So if you take, say, we'll just assume 8, 9, the possible combinations of Q. Okay, Q cannot have 9 value, then R will not have any possibilities. So 8, is it possible to have 8? We'll see. So let's say Q is 8 and R is 9. So 9 plus 8 is 17. So P can be taken as 3. 9 plus 8 is 17 plus 3, 20. So 3, 8, 9 is a possible combination where Q is 8 and Q can all have all these values, and we can find different values of P, Q and R so that it satisfies P plus Q plus R is 20. So 8 is also possible. So the possible P, but Q cannot have 9. If Q is 9, R cannot be greater than P, and we cannot find a digit where that is greater than 9, a single digit that is greater than 9. So Q cannot be 9 and Q cannot be 1. So all other values Q can have. So 1, 2, 3, 4, 5, 6, 7. So the number of possible values of Q is not 6 but 7. So Q can have all these values which satisfy this equation. So this is wrong. So total number of possible values Q can have is 7. So the correct answer is 1 only. So 1 only, A, 1 only is the answer. The solution to question 28 is A, 1 only. I hope this is clear. If you have any doubt, do comment. I will try to address it. This is little confusing question, but I hope you understood what I meant. That P can have different 2, 3, 4, 5, 6, 7, 8. Yeah. When Q is 2, P will be 1. When Q is 3, P can have 1 or 2, and we can find an R such that P plus Q plus R is 20, right? I'll just verify that also. If P 1 Q, we have 3. So our R has to be, in this case, R has to be, if P plus Q plus R equal to 20, R has to be what? R has to be 17, which is not possible. The maximum value R can have is 9. But you should also remember we had a different case where P plus Q plus R is 10. That is also possible. So if that was the case, P plus Q plus R equal to 10, P can have 1, Q can have 2, and R can have 7. So 1, 2, 7. That is possible. So Q can have 2 value also. So smallest value is also possible in this case, and highest value is also possible in this case. So we have to consider that. So I will just show what this 1, 2, 7 means. So P 1, Q is 2, 2, and R is 7, 7. So this means 7, 8, 7 plus 2, 9, 1, 10, 1. Again 10 plus 1, 11. So see, for Q equal to 2, P equal to 1, R equal to 7, this whole situation satisfies. P is less than Q is less than R also. Every condition satisfies. So Q can have 2 and Q can have 8 when P plus Q plus R equal to 20 case. So Q can have all the values and P can have 1 to 5 and Q can have 2 to 8. So this is the combination. So that I hope that is clear. Solution to 28 is A, 1 only. Next question, question 29. What is the number of selections of 10 consecutive things out of 12 things in a circle taken in the clockwise direction? So we have a circle and we have 12 things. 1, 2, 3, 4, 5, 6, 7, 7, 8, 9, 10, 11, 12. So we have 12 things. So we have to select 10 consecutive things in the clockwise direction. So we have to find the number of selections that we can make in such a manner. So the moment we select a beginning person or beginning thing, we don't have much choice here. When we start with here, the only choice left, there is only one possibility, that is selecting 2, 3, 4. Since we are selecting consecutive items in a clockwise manner, the only choice we can make is 2, 3, 4, 5, 6, 7, 8, 9, 10, from 1 to 10. So one choice we can make is from 1 to 10 in this clockwise manner. So second choice we can make will be changing the person from person with we started. So if we start with 2, then we can make the selection 2 to 11. 2 to 11 is another possibility. Then we can choose our third case will be 3 to 12 and fourth case will be 4 to 1. So if we begin with 4 and if we select the 10 consecutive people, we'll get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we will end with 1. Similarly, how many choices we can, how many unique selections we can make, it depends on the number of possibilities we can begin with. So which is what? 12 cases. So we'll have such 12 cases. If we continue, we'll have 1 to 10, 2 to 11, 3 to 12. Similarly, we have at the end we'll be having at the end our 12th choice will be 12 to if we begin with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12 to 9. So this will be our 12th case. So we'll have 12 unique cases here. So our solution will be solution to question 29 is C12. So you should remember one thing, it is not a circular combination case. It is not a circular combination. Second, it is not a case of selection. We cannot apply combination here since we are restricted. Not combination. That is, we can if you say 12C10, this will be wrong. It will not be 12C10. So since we cannot randomly pick 10 people, once we select the first person, there is only one choice, that is to select all the 10 consecutive persons in the circular manner. If we were allowed to start with 1 and move in this direction, we would have got a different selection, but that is not allowed. The only one case allowed is 1 to 10, this case. So it is not a combination case, it is not a circular combination case. So don't get confused here. So only possibilities here is 12 cases that I explained: 1 to 10, 2 to 11, 3 to 12, similarly 12 to 9. So such 12 cases are the only possible combinations here. So solution to question 29 is C12. Question number 30. If today is Sunday, then which day is it exactly on 10 raised to 10th day? So here, to find what day is today, we need to find first the remainder 10 raised to 10 will have when divided with 7. So why is that? When we have the remainder, we can add that remainder to this Sunday and find which day is today. I'll explain that as we solve. So first we need to find the remainder of when 10 raised to 10 is divided with 7. So there are two ways to do that. One is the difficult way. I think UPSC wants the aspirants to do it in the difficult way. I don't expect UPSC thinking. I don't think UPSC thinks that the aspirants know the complicated mathematics concept to solve this question. So the easiest harder but simple way to do that is to just divide 3 4 5 6 7 8 9 10 by 7. So you will see a pattern happening. So if there was only 1 0, what would happen? Our remainder would be 3. So we'll just track that. If we had only 1 0, our remainder would be 3. And if we had 2 zeros, that we are bringing down second 0, what would happen? 7 into 4, 28. We will have a remainder of 2. So if we had 2 zeros, we'll have a remainder. This is number of zeros, and this is remainder. Okay. So if we had 1 0 only, our remainder would be 3. If we had 2 zeros, our remainder would be 2. And we can bring down 0. So again 2, 14. So if we had 3 zeros, our remainder would have been 6. And so we will bring down one more 0, 60. So then we have 8, 56, 4. So if we had 4 zeros, our remainder would have been 4. So we will write 5, 35, 5. We had 5 zeros, our remainder would have been 5. Again bringing down 0, 7, 49, 10. So that means 1, 7, 3. So now if you see, if we had 6 zeros, our remainder would have been 1. Now from 7th 0, this cycle repeats. For 7th 0, the remainder would be 3 again. 8th 0, remainder would be 2 again. And this cycle repeats. So as you can see, we have 10 zeros. So we don't have to divide entirely. So 7th 0, if we had 7 0, we will have remainder 3, 8 0 2, 9 0 6, 10 0 4. So our remainder would be 4. So so our dividing this will give remainder as 4. So we got our remainder equal to 4. Now Sunday, if today is Sunday, then which day is exactly on 10 raised to 10th day? So if, let's just confirm, like if this number was, say, for easiness, say exactly on 3rd day. If it was exactly on 3rd day, what would happen? Sunday, and we add 3 to it, right? 3rd day. 3rd day means first day is Monday, second day is Tuesday, 3rd day is Wednesday. So we'll add 3 to it. If it was 7 days, 7th day, what would happen? 7th day means first day is Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. On 7th day from Sunday means Sunday itself. So we that is the importance of remainder, having the remainder with dividing with 7. So whatever the remainder is, so 8th day means just adding 1 to Sunday, and that will be a Monday. So we will just find the remainder and add to Sunday to find the number of the current day. So we got our remainder as 4. So our day will be Monday, Tuesday, Wednesday, Thursday. So our day, fourth day, how did we get 4? 4 is the remainder when we divide with 7. So as I showed you, 8th day means just adding when you divide 8 with when you find the remainder with 7, dividing 8 with 7 gives remainder 1. So 8th day is as good as adding 1 to it and finding the answer. So similarly, we found out 10 raised to 10 by 7 gives remainder 4. So we just add 4 to Sunday, that is 1, 2, 3, 4. So 4th day will be a Thursday. So solution to question 30 will be B, Thursday. So this is the answer to question 30. Now, as you can see, this solution involves lot of steps. You have to do lot of multiplication, divisions and all. This may take some time in the exam hall. So there's another way to solve this question, which involves knowing a little a mathematical concept called Fermat's little theorem. So I don't think UPSC expects everyone to learn Fermat's little theorem, modular equivalence and all. So don't get intimidated by this solution I am going to discuss now. If it is too confusing for you, just stick with this standard solution. Though it may take some time, this is good enough. So anyway, so Fermat's little theorem, if you know Fermat's little theorem and the concept of modular equivalence, you don't have to do any of this multiplication and steps. You can quickly find the remainder and find the answer. I'll show you how. So Fermat's little theorem says a raised to p is equivalent to a mod 10. What this means is, a mod p. P is a prime number and a be any positive integer. So what this means is a raised to p when divided with p will have same remainder as a when divided with p. So a raised to p and a when divided with p will have same remainder. This is what Fermat's little theorem says. So here, as you can we can write using this Fermat's little theorem, we can quickly write 10 raised to 7 is same as 10 mod 7. So what this means is 10 raised to 7 will have same remainder as 10 when divided with 7. So what is so that is 10 raised to 7. We can also write 3 mod 10, or 10 divided with 7 will have remainder 3, or 10 raised to 7 will also have remainder 3. So 10 raised to 7 and 3 will have same remainder. Sorry, again I made a mistake. 7 modes, 3 mod 7. So when divided with 7, 10 raised to 7 will have same remainder, or 3 and will have same remainder, which is 3 itself. So we can quickly find what is the remainder when 7 is divided with 10 raised to 7. Now we can also find, we know 10 is equivalent to 3 mod 7, or 10 raised to cube is equivalent to 3 cube mod 7. So what this means is 10 cube will also have same remainder as 3 cube when divided with 7. What is 3 cube? 3 cube is nothing but 27. So we know that 7 3s are 21 and we'll have 6 as remainder. So 10 cube will have 6 as remainder. 6 remainder. Since 10 cube and 3 cube will have same remainder when divided with 7. As you can see, 27 is remainder 6 is we can quickly find in our mind. So 10 raised to 7 will have 3 remainder and 10 cube will have 6 remainder. That means 10 raised to 7 into 10 raised to 3 will have 6 into 3 same remainder as 6 into 3. So that is 18. So 18 when divided with 7 is nothing but 2, 14 and 4. So remainder of 10 raised to 10 will be 4. So using this concept, we can quickly find in our mind that the remainder will be 4. So knowing these concepts, that is modular equivalence and Fermat's little theorem, we can quickly find the remainder of larger number also. More complicated questions we can handle using these concepts. That's why I just discussed. So once we get the remainder as 4, we can quickly find our answer in the same manner as Monday, Tuesday, Wednesday, Thursday, and Thursday is the answer. So we don't have to do all this. Once, if you know, we can just write in 2 steps that 10 raised to 7 into 10 raised to 3 remainder will be 6 into 3 and 18. We can quickly do it in our mind. it will be 14. 6 into 18 minus 14 is 4, and the remainder will be 4. So yeah, okay. So that is a concept. You can read about this. So it is Fermat's little theorem. So if you are interested to read about this, do read this concept. So read these two to get to understand this. If you didn't understand any of this, you can read these two concepts to get familiar with. I don't as I said earlier, you don't have to read these two and understand all these concepts. You can stick to the standard way and solve this question like this also. It will take some more seconds, but you will definitely get the answer. So even in this exam, there was another question which wanted the aspirant to solve the question in the same manner. So I am thinking UPSC want the aspirants to do this solution only. So but if you know this, you can save some time. That's why I just discussed this solution also. So anyway, solution to question 30 is B, Thursday. Next question, question 31. There are 3 traffic signals. Each signal changes color from green to red and then from red to green. The first signal takes 25 seconds, the second signal takes 39 seconds, and third signal takes 60 seconds to change the color from green to red. The duration for green and red colors are same. At 2 p.m. they together turn green. At what time will they change to green next simultaneously? So this is a classic question that asks for LCM. So here it is given green to red takes 25 seconds, 39 seconds, and 60 seconds respectively by each signals, second signal and third signals. So total time it takes for each signal to go from green to red and red to green will be 50 seconds. 39 to 2, that is 78 seconds and 120 seconds. This is the time it takes for each signal to go from green to red and then red to green. So we have this. So it is given at 2 p.m. Each signal together turn green. At what time will they change to green next is the question. So basically it happens at the LCM time. So it takes LCM time. So you have to find LCM. So if you factorize each element, we get 5 into 10. 10 is 5 into 2. And here it is, if you divide with 2, you have 39. 2 into 39 is 3 into 13. Okay. So here 2 into 6, which is 3 into 2 into 10. So 5 into 2. So this is 120. So now we can find LCM. So first we take 113. Now 2 5s, then 1 2 3 2s. So okay, before 3, 1 3, there is only 1 3. So 1 3 and 3 2s, right? 2 into 2 into 2. So this is the LCM. This is the total seconds that will take for all these signals to change into green simultaneously. So we want minutes from this. So we'll divide it with 60. For 60 we can write 3 into 2 into 5 into 2, 10. So we'll just cancel out 3 2 3 2, 1 5 will cancel out, and 1 2 will cancel out. So what is left is 5 into 2 is 10. 5 into 2, 10 and 13 into 10. So 130 minutes. So we got our answer as 130 minutes. 130 minutes is nothing but 2 hours and 10 minutes. So this is nothing but 130 minutes is nothing but 2 hours and 10 minutes. So from 2, if 2 hours and 10 minutes, after 2 hours and 10 minutes, it becomes 410. So our solution to question 31 is B, 410. So for people who didn't understand how LCM is the time at which all the three signals change simultaneously to green, you can check out the video I have done on LCM. I have created a playlist called Basic Mathematics Concepts, and there is a video on LCM. Once you go through that video, you will understand how LCM is the time at which they simultaneously change to green. So even if you don't understand, if you are not familiar with how to find LCM of these numbers, even that is discussed in that video. You can check that out to have a more to have better understanding of this topic. So I hope that is clear. So the solution to question 31 is B, 410. Next question, question 32. 40 children are standing in a circle and one of them has a ring. The ring is passed clockwise. Child 1 pass on to child 2 pass on to child 4 pass on to child 7, and so on. After how many changes will the ring, including child 1, will the ring be in the hands of child 1 again? So what is happening is there is a circular arrangement. First person is standing here, second person is standing here, 3, 4, 5, 6. Similarly, we have, say, 40, 39, 38, 37. So similarly, we have such arrangement. So first person gets the ring first, and then it is passed on to second person pass on to fourth person pass on to seventh person. That's how it is said. So first person pass on to 2 pass on to 4 pass on to 7. So the pattern here is like, if you see, +1 +2 +3. So next person will be +4, so that is 11. 7 will give the ring to 11. So if it goes like this in a circular manner, how many passes will it take for one to get the ring again? That is the question. So we'll see. So in our first pass, 1 is given to 2, so +1. So in our second pass, 2 will be given to +2, 4. Similarly, we can write down all the passes. That will be the easier steps. For 7. In the fourth pass, we have 7 plus 4 is 11. In the fifth pass, we have 11. So as you can see, the options are 14, 15, 16, 17. So it will take at least 14 passes. So we'll have to write 14 cases. So we can fastly write 15, 16, 6, 16, 6, 22, 7, 22 plus 7, 29, 8, 29 plus 8, 7, 9, 37 plus 9. So if you see what happens, 37. So 37th person plus 9 means 1, 2, 3, 4, 5, 6, 7, 8, 9. So sixth person will get the ring again. So that is 37 plus 9 is 46. So 40, after 40, again 1, 2, 3, 4 repeats. So 46 means sixth person gets the ring again. So ninth pass, sixth person is getting the ring again. In the 10th pass, plus 10. Okay, sorry. In the 10th pass, 6th person plus 10. 16th person again gets ring. 11, 16 plus 11 gives 27. Sorry. 27. 12th pass, 27 plus 12 gives 39, 13th pass, 39, 13, which is 39 plus 13 is 52, but we will write 12, 40 plus 12, so 12th person gets, so 12, 14th pass, 12 plus 14, 12 plus 14 is 26, so 15th pass, 26 plus 15, 26 plus 15 is how much? 41. So 41, instead of 41 we will get 1. So again 1 is getting the ring, so including 1, 15th pass 1 gets the ring, so it says including child 1, so 15th pass will be counted, so total 15 passes it takes to for the 1 to get the ring again. So solution to question 32 is B, 15. Next question, question 33. What is the middle term of the sequence Z, Y, 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 X, 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 W, 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 W up to A? So this is the sequence given. So as you can see, Z is repeating 2 times, Y is repeating 3 times, X is repeating 4 times, W is repeating 5 times, and it goes like that. So to find the middle term, so we can write this 2, 3, 4 up to what? A is repeating how many times? How can we can find that? Say here Z is a 26th alphabet, so if you can see 28 minus 26th alphabet is 2, and similarly Y is 25 alphabet, 28 minus 25 is 3. So 28 minus the alphabet, the which number will give what? This number, how many times it is repeating. So 28 minus A is what? 1, first alphabet. So A is repeating 27 times. So 27. We get this as the sequence. So now as you can see, Z is repeating 2 times, Y is repeating 3 times, W is repeating 4 times, and A is repeating 27 times. That is what I have written here. Now what is the middle term? To find the middle term, what we need to do? Find all the number of alphabets, which is nothing but 2 plus 3 plus 4 up to 27. So we need to add all these up and divide by 2, divide it by 2 to get the middle term. So how we can add all this term? We can use the sum formula in a sequence. This is a sequence with the difference of 1. So we can easily use the sum formula. Sum formula in a simplified manner is nothing but first number plus last number into total number of numbers by 2. This is the sum formula, sum of sequence formula. So here first number is 2, last number is 27. Total number of numbers in here will be what? 26 alphabets are there. So we have 26 numbers. So 26 by 2. So if you do it, we get 13 into 29. So 13 into 29 is nothing but, so 30 into 13 will be 390. 390 minus 13. This is also, we can write 390 minus 13 or 377. So 377 is 29 into 13. And when we have 377 numbers, what will be the middle term? 377 by 2. Since it's an odd number, 377 by 2 plus 1. So why, if we have 4 numbers, say we have 7 numbers, how will we find the middle term? Middle term is nothing but 4, that we can find by 7 by 2 plus 1. 7 by 2 without fraction, that is 7 by 2, 7. So or we can just write 7 plus 1 by 2, 7 plus 1 by 2, or 8 by 2, so which is 4. So this is how we find the middle term. So similarly we have 377 terms, so 378 by 378 by 2 is so 1, 17, 8, 16, 189. So 189th term is the middle term. So we got our 189 as the middle term. So now what does that mean? So if you expand this, if you expand this to 1, to 1, this is x to 3, and this is x to 4. Similarly, if you expand this, 1 2 3 4 5 6 7 8 9, 189th term will be the middle term. So we don't have that expansion. So what we do, we know that if when we keep on adding this 2 plus 3 plus 4, some at say at some number n, at some number n, when we keep on adding it, we will get 189. So if some n, 2 plus 3 plus 2 plus 3 plus 4 plus up to n gives 189, what does that mean? That middle term is the last number, last person in this n. Okay, so belong to this alphabet, whatever this alphabet is, will belong to that alphabet. So again we can use the sum formula, again a plus l plus n by 2. So that means 2 plus, here last number is our n, into total number will be here n minus 1, right? The 2 plus 3 plus 4 up to n, if since it is starting with 2, total number of digits will be n minus 1 by 2. So we have to find some n such that 2 plus n into n minus 1 by 2 gives 189. So this is a quadratic equation. You don't have to solve this quadratic equation. You can see whether there is any easy formula. Some values of n satisfies this. Okay. N minus 1 into n plus 1. We can bring 2 to the other side if you want. So 189 into 2 is nothing but 378. So if you factorize 378, you can see 378 is 378 by 3 1 3 7 2 6 18 9, 129 into 3. So this again goes 3, 129. 129 by 3 is 4 into 3, 12, 9, 43. So 43 into 9, or we have 43 into 9. Sorry, there is a mistake somewhere. Where did 2 go? 378. Okay, just sorry for that. I'll just do it again. So we know that 378 is 189 into 2, or 189 goes with 3, which is 63, right? 6 into 3 is 18, 63. So 63 into 6, again it goes with 3 again, so 63, 21 into 6 into 3, 18. So if you see, it is 21 into 18, this 378. So if you see it, we need n plus 2 into n minus 1. So looking at this, we can see n equal to 19 fixes this equation, right? 19 minus 1 is 18. This will be 18. 19 plus 2 will be 21. 21 into 18. So n equal to 19. So we get n equal to 19. If you want, you can do it in a solve it as a quadratic form. It's not needed. Yeah, we'll see n equal to 19 is the by factorizing we can see what all possibilities are there. So yeah, n equal to 19 is the possibility. So we got this as 19. So now we can see, we need to know what alphabet, since it's in the reverse order, what alphabet is mapped to the 19th number. So here, as you can see, 2 is 26th alphabet is mapped to 2. First alphabet is mapped to 27. So similarly, we already saw the formula 28 minus n, the n, this 19 is we got as 19. So n is nothing but 28 minus 19, which is, as you can see, 9. So ninth alphabet. We have ninth alphabet as our answer. What is ninth alphabet? A, B, C, D, E. So A, B, C, D, E, F, G, H, I. 1, 2, 3, 4, 5, 6, 7, 8, 9. So ninth alphabet is I. So our answer will be B, I. So I know this is a complicated answer. But it involves a lot of calculations. It is taking too much time also. So I don't know why they come up with such questions in the exam hall. I'm not sure whether there is any simpler method to solve this. This is all I can think of. Otherwise, you will have to just write every number and add it up individually without using any formula. That will take more time. This is more easier, I feel. Yeah, anyway, this is my solution. If someone knows any simpler solution, do comment. I will look into it. Anyway, this is the solution to question 33. Option B is the answer. I is the solution. Alphabet I is the middle term if we arrange it like this. If you find this solution too confusing or too difficult, you can also do this question in a simpler way. Probably that will take more time. That's why I didn't go through that solution through that method. I'll show you how. So in that method, you will have to best way is to list all the alphabets. So we'll just list all the alphabets. A is repeating 27 times. So B is repeating 26 times. C is repeating 25 times. D 24. E 23. F 22. G 21. H 20. I 19. J 18. K 17. L 16. M 15. N 14. O 13. P 12. Q 11. R 10. S 9. T 8. U 7. V 6. UV W 5. X 4. Y. UV W X Y 3. Z 2. So we got all the in the order. Now we just sum it up. Instead of using any formula, you just sum it up. Instead of summing up, summing up, we'll just do one thing. We'll just add this and write, and we'll go. 2 plus 3 is 5. 5 plus 4 is 9. 9 plus 5 is 14. 14 plus 6 is 20. 20 plus 7 is 27. 27 plus 8 is 35. 35 plus 9 is what? 44. 44 plus 10 is 54. 54 plus 11 is 65. 65 plus 12 is 78. 78 plus 3. One mistake you make, everything messes up. So be careful when you do such solution. Okay, 54 plus 11 is 65. 65 plus 12 is 78. 78 plus 13 is 91. 91 plus 14 is 105. 105 plus 15 120. 105 plus 15 is 120. 120 plus 16 is 136. 136 plus 17. 136 plus 17 is 146. 146 plus 7. 153. 153 plus 18. 163 plus 8. 171. 171 plus 19. 189. 189. 189 plus 20 is 209, right? 189 plus 20. Okay, 209 plus 21. So 230. 230 plus 22, 252. 252 plus 23, 275. 275 plus 24, 299. 299 plus 25, 324. 324 plus 26, 350. 350 plus 7, 377. So as you see, we got all the numbers we need. Earlier we got 377 as our sum. We individually summed it up. If you don't know the formula, you could do individually. The advantage of summing up like this is all the number we need. So we the moment we get 377, 377 plus 1 by 2, we get 189 as our middle number, and we already have that 189. 189 we got 171 plus 18. Sorry, 170. We added 171 and 19. Sorry, 18. All right. 189 is. Let me just see. 2 plus 3, 5. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. 17th number. So this is 5. So from here, 17th number will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So the reason I had to do that was I didn't write it neatly. If you write it neatly, you will clearly see 189 will be I. So quickly you can say I is the middle. So I am not sure whether which one took more time. This does not involve any formula. So most of the question in the UPSC exam doesn't want you to remember any formula. You can do it in a simple manner, but it will take time. Knowing formulas will make things simpler. You will be able to do questions in a faster way. So even this is possible. If you do in this way also, you can find the answer. So this is one way to do it. Or if you know the formula, as I see, I haven't written any sum, I haven't calculated any sum, so this is more error free. So here, since lot of addition is there, even if we miss by 1, it will be too complicated to we will not notice, and it will be too complicated to find that where we made error. So since we got the sum in the first go itself the correct, so we got our answer very quick. Anyway, this is also a solution. You can choose whichever solution method you want. Yeah, okay. So anyway, this is one. This is the solution to question 33. Solution to question 33 is BI. Next question, question 34. Question, is P greater than Q? Statement 1, PQ is greater than 0. Statement 2, P square is greater than Q square. Which one of the following is correct in respect of the question and the statements? First option is the question can be answered by using one of the statements alone but cannot be answered using the other statement alone. Second option, the question can be answered by using either statement alone. Third option, the question can be answered by using both the statements together but cannot be answered using either statement alone. And fourth option, the question cannot be answered even by using both the statements together. So we'll see what is the answer. So first we will analyze what statement 1 and statement 2 means. Statement 1 means P into Q is greater than 0. So that means both will have the same sign. That is P and Q will be either greater than or equal to 0. Is greater than 0, so cannot be 0. So it's either greater than 0, positive numbers, or P and Q are less than 0. This is the only conclusion that we can make. They have both same sign. So with that information we cannot answer is P greater than Q. So statement 1 alone cannot answer whether P is greater than Q. So we will see statement 2. Statement 2 says P square is greater than Q square. So what does this mean? Absolute value of P is greater than absolute value of Q. That is, if you forget the sign, whatever sign P has and Q has, then the absolute value will be of P will be greater than Q. So this could mean this does not answer the question is P greater than Q. I will show you one example. Say P's value is 4 and Q's values is 3. So P square is greater than Q square. Absolute value of 4 is greater than absolute value of 3. So in this case, what P is greater than Q. So P square is greater than Q square. But let's take another example, minus 4 and minus 3. So in this case also P square is greater than Q square. P square is greater than Q square means minus 4 square is 16 and minus 3 square is 9. So P square is greater than Q square is satisfied here, but as you can see P is less than Q. So when P square is greater than Q square, both the conditions P greater than Q, P can be greater than Q or P can be less than Q. So we cannot answer this whether P is greater than Q or P is less than Q from statement 2 alone. So now the question is whether when both the statements are true, statement 1 and statement 2 are true, we can answer whether is P greater than Q or not. So we will think of one example. So as you can see, in the statement 2, absolute value of P is greater than absolute value of Q. So from statement 1, it means either P is positive or Q is negative, nothing more. So if you combine both the statements, there is nothing. So let's say in the first scenario, that is P and Q have a greater than or equal to P and Q are positive. Let this be the first scenario and second scenario. From statement 1, we don't know whether it is first scenario or second scenario, but in the first scenario, when P and Q are positive, and statement 2, we can say that P is greater than Q. But we don't know whether it is first scenario. It could be second scenario. In second scenario, both P and Q are P and Q are less than 0, or P and Q are negative numbers. In that negative number case, combining statement 2, we can say for sure that P is less than Q. So in both scenarios that is given by 1, we'll arrive at a different answer for is P greater than Q. So combining these two, whether if someone asks is P greater than Q has a solid answer, we don't. The statement 1 does not give enough information for us to know whether it is situation 1 or situation 2. So for that reason, we will not combining the two statements, we will not be able to say is P greater than Q or P less than Q. Both is possible. I'll show you one example. That is making statement 1 and 2 true, and we'll getting two answers. So statement 1 and 2 true. As I mentioned earlier, let's consider 4 and 3. P's value 4 and 3. So statement 1 is what? PQ is greater than 0. So 4 into 3 is greater than 0. That is satisfied. And p square is greater than q square. That is also satisfied. So from this two, we can see we took a case p greater than q and both the statements got satisfied. And in another case, we will take -4 and -3. As you can see, pq is greater than 0 there also. So -4 into -3 is 12, positive 12, that is greater than 0, that is satisfied. And p square is greater than q square. So p square is greater than q square is also satisfied. So, but we can see p is less than q. So though both the statements are true, we are getting two different answers. So we cannot say for sure the question is p greater than q. We cannot answer for sure whether is p greater than q or not, even after using both the statements. We may have two different results. So the solution to question 34 is the question cannot be answered even by using both the statements together. So solution is D. Solution to question 34 is D. Next question, question 35. Question: is p plus q minus r greater than p minus q plus r, where p, q and r are integers? Statement 1, p minus q is positive. Statement 2, p minus r is negative. Which one of the following is correct in respect of the above question and the statements? So options are: the question can be answered by using one of the statement alone, but cannot be answered using the other statement alone. The question can be answered by using, second option is the question can be answered by using either statement alone. Third option is the question can be answered by using both the statements together, but cannot be answered using either statement alone. And fourth option is the question cannot be answered even by using both the statements together. So these are the four options. We'll see what we want to prove. Our question is p plus q minus r is greater than p minus q plus r. This is a question. Whether we are able to answer using the statement, whether we are able to answer this question using the given statement is the question. So first statement, we'll analyze first statement. First statement is p minus q is greater than positive, greater than 0. That implies p is greater than q. So this is the only information we have. There is nothing, there is no information of r here. So definitely we cannot answer anything from this. P is greater than q. Whether this statement holds true or false depends on r. So that there is no information on r. So statement 1 alone cannot answer for sure. So we'll see statement 2. Statement 2 says p minus r is negative. So is less than 0. That implies p is less than r. So p minus r is negative means p minus r is less than 0 or p is less than r. Now statement 2 does not have any information about q. So again, statement 2 alone will not be able to, using statement 2 alone we cannot answer the question. So but using statement and 1, so these are the statements. So from 1 and 2 combined, we have one more information. P is greater than q and p is less than r. So that means what is the order? R is p is less than r, right? So r is greater. So r is less than. So r is greater than. So we go using statement 1 and 2 together, we have r is greater than p is greater than q. So 1 and 2 together we have r is greater than p is greater than q. Now we will look at this statement is the question. So question is nothing but p plus q minus r. If you rearrange, is whether greater than p minus. So we will just use p minus. We take minus sign outside, we get q minus r. So whether p plus q minus r is greater than p minus q minus r. So but from this figure we know that r is greater than q. So q minus r is definitely a negative number. So q minus r is a negative number, right? R is greater than q. That implies r minus q. p minus q, sorry, q minus r is less than 0, right? Q minus r is less than 0. We have this from statement 1 and 2 together. Remember this, we are using statement 1 and 2 together. We know q minus r is less than 0. So if you see, p plus p is a p, let p be any number. From p a negative number is adding, so that means it will be less than p, right? This side will be less than p, and from p a negative number is getting subtracted, that will be greater than p. So this side, p minus q minus r will be greater than p plus q minus r. When we combine 1 and 2, we will get, so we can clearly see that since p is a negative number is subtracted by p, let's, for better clarity, let's say q minus r is, let's say q minus r is a negative number, and let's say it is minus k. Okay, we will substitute q minus r with here, so that means p minus k and greater than p minus k. So p plus k. Is p plus k less than p minus k? Definitely not. So the answer to this solution is no. So so when we combine 1 and 2, we will be able to answer the question, is p plus q minus r greater than p minus q plus r, by an answer no. So it is not true. So when we combine 1 and 2, we will be able to answer this question. The answer will be no, but we will still be able to answer the question. So we can say solution to question 35 is the question can be answered by using both the statements together, but cannot be answered using either statement alone. So solution to 35 is C. That is, we need both the statement. If we have both the statements together, we will be able to answer the question, and that answer will be no. So I hope this is clear. That is the solution to question 35. C. Next question, question 36. In a party, 75% took tea, 60% took coffee, and 15% took both tea and coffee. No one taking milk takes tea. Each person takes at least one drink. Question is, how many persons attended the party? Statement 1 is 50% took milk. Statement 2 is number of persons who attended the party is 5 times the number of persons who took milk only. So question, which one of the following is correct in respect of the above question and the statements? A option is, the question can be answered by using one of the statements alone, but cannot be answered using the other statement alone. Option B is, the question can be answered by using either statement alone. Option C is, the question can be answered by using both the statements together, but cannot be answered using either statement alone. Option D is, the question cannot be answered even by using both the statements together. So we'll see what is the given information. So from the first paragraph, we understand that there are some people who took tea, there are some people who took coffee, there are some people who took milk, and there are some overlaps. So what are the number of people who, so we'll just draw a Venn diagram for the given information first. So let this be the people who took tea. So it is given 75 is the number of people who took tea, and 60 is the person who took coffee, and 15% took both tea and coffee. So there is an overlap between tea and coffee. Let's say this is the overlap. So this is, let this be coffee, and it is given 60 people took coffee, and the overlap region, that is people who took both tea and coffee here, this region, it is given, it is 15. So now from this and it is now let's draw the diagram of milk also. So no one taking milk takes tea. So so that means if you draw a circle of milk, it shouldn't overlap with the tea circle. So let's draw another circle like this. It doesn't overlap with tea, but it overlaps with coffee. So let this be another circle with milk. This region represent the people who take both coffee and milk. That is permissible. It is only said no one taking milk takes tea. So anyway, it is also given each person take at least one drink. So all the people are covered within this circle. So there is no person that is outside the circle. So that is given. Now, so we can mark the individual regions here if you want. So see, this yellow region is the people who take T only. That is nothing but 75 minus 15. 75 minus 15 is what? 60. So we know this yellow region is 60. And let's mark this red region. We know this red region is 60 minus 15, which is nothing but 45. We know this red region is 45. There is some overlap region here. We don't know how many people are in this region. We'll have to see. So this is the given information. Now we'll see what we can infer from the statements given. So first statement is 50% took milk. 50 took milk means total this region will be 50. This total region will be 50. We don't know how much people belong to this group. So from this statement alone, can we find how many persons attended the party? To find from this information, as you can see, to find the number of people who attended, to find the number of persons who attended the party, we need to know how many people are there in this group. Otherwise, we will not be able to know how much double counting is there in this 45. So this group, this is needed. We need to know what is this figure. So now, and let's go with the statement 2 now. With statement 2, it is given number of persons who attended the party is 5 times the number of persons who took milk only. So let's analyze the statement 2. Statement 2 says number of persons who attended the party is 5 times. So from this, what is the number of persons attended the party? We will assume let this be okay, I'll just draw a region. I will draw a region, blue region. What is this blue region? Blue region is nothing but milk only, people who drank milk only. This is the milk only group. Let that be X. We don't know what that X is. So what this becomes? This becomes 50 minus X. Okay, this is 50 minus X. And what? So there is one more region. I'm not sure. This is all getting confusing, but there is no other way. So we'll draw another region like this. What is this? This is coffee only region. So coffee only, milk only plus tea only will give total number of people who attended the party. So this is tea only. This white region is this white region. This white region is coffee only, and this blue region is milk only, and the common people added separately. So we'll just do that. We'll just add all the statements to from statement 2. We are processing statement 2 only. So from this we have 60 plus 60 is the T only group, plus 15 plus 15 plus 45, not 45 include 50 minus X also. So instead of 45, we will write 45 minus 50 minus X. 45 minus 50 minus X. 50 minus X. uh, plus, okay, that doesn't make sense. Okay, 50 minus x is added, so that will cancels out. Okay, so what happened, so when we add all the region and without double counting, what happens is we can just add this red region and x region. So red region means plus 45. 45 has no double counting if we just eliminate this part and add x all. So x, this gives the total number of people who attended the party. This, it is given as 5 times the number of persons who took milk only. So this is 5x. So x is the number of people who took milk only, and 5, it is given 5x. So if you see, we can easily find out what x is. 4x is nothing but 60 plus 15 plus 45, which is 50. 60 plus 60, 120, and x is equal to 30. So we have x is the person who took milk only is 30, and total number of people who attended will be 60 plus 120 plus 30, that is 150. Total people attended will be 120 plus 30 equal to 150. So as you can see, we didn't use the statement 1 anywhere in this equation or solution. So statement 2 was sufficient to find what is the total number of people who attended the party. Statement 1 was turned out to be not useful to find the total number of people who attended the party. Was so I hope that is clear. So statement 2 alone is sufficient, and statement 2 is not useful. So question can be answered by using one of the statements alone, but cannot be answered using the other statement alone is the solution. So A is the solution to question 36. A is the answer. So once we have this, the total number of people who attended is 5 times the number of persons who took milk only. We can finally find what x is, that is a person who took milk only, and then use that to find the total number of people who attended the party. So yeah. So that is the solution to question 36. A is the solution. Next question, question 37. Consider a 3-digit number. Question, what is the number? Statement 1, the sum of the digits of the number is equal to the product of the digits. Statement 2, the number is divisible by the sum of the digits of the number. Which one of the following is correct in respect of the above question and statements? A, the question can be answered by using one of the statements alone, but cannot be answered by using other statement alone. B, the question can be answered by using either statement alone. C, the question can be answered by using both the statements together, but cannot be answered using either statement alone. D, the question cannot be answered even by using both the statements together. So we'll see. It is given it is a 3-digit number. Now the sum of the digits of the number is equal to the product of the digits. Let's say the number is x, y, z. So that means x plus y plus z is equal to x into y into z. So x into y into z. That is the first statement. So we can think of a lot of numbers like this. So first statement alone will not be able to decode the number. So let's look at the statement 2. Statement 2 says the number is divisible by the sum of the digits of the number. So let sum of the digits of the number be, let x plus y plus z is equal to k. That implies the number x, y, z is k into some n. So n be any positive integer. So our number is in this form. So this is the statement 2. So even here, The number is divisible by the sum of the digits of the number. If you take that alone, let's see whether statement 2 alone can help us find the number. So the number is divisible by the digits. So let's say let's think about different sums. So even in first statement 1 and statement 2, sum is there, sum of digits is there. So sum of digits cannot be what is the minimum sum that this 3-digit number will have? The minimum sum, can it be 2? So is it given that all the 3 digits are unique? No. So if 2 is only given, statement the number is divisible by the sum of the digits of the number. So so let's think. So x plus y z, the sum x plus y z can be 1. So can it be 1? So if it is 1, we will have plenty of numbers. So any number x, y, z will be divisible by 1. So if the sum is 1, we will have multiple numbers. Just think about any number, and how can x, y, z be 1? It's only when it's like x is 1, y and 0, y and z are 0. In only this case, we will have a 3-digit number and sum as 1. So as you can see, 100 is divisible by the sum of the digits, that is 1. So we can think of any number and so this is the only number that we can it gets divisible. So if the sum is 1, we will get the number as 100. There is no other 3-digit number with sum of the digit as 1. So that is one case. So let's think about the second case, x plus y is equal to 2. So in this case, there are multiple numbers, but let's think 200 is one possibility. 200 is divisible by 2, that is one possibility, and 101 is not divisible by 2. So any number other than, so even when sum is equal to 2, the number we will get the number as 200. So here, as you can see, if 2 alone was given, whether it is 100 or 200 we cannot know. So statement 2 alone we will not be able to answer what is the number using statement 2 alone. So we have already got two possibilities, 100 and 200. When the sum is 1 and sum is 2, so we can check all other sums and we will get multiple other options. So statement 2 alone will not help us to find the number. So now we will think about statement 1 and 2 together. We'll see whether statement 1 and 2 together will help us to find the number. So when we think x plus y is equal to x, y, z, whether sum can different sum, whether x plus y, z can be 1? No. Since if when 1 and 2 are together, if sum is 1, that implies x into y into z is equal to 1. The only possibility is 1, 1, 1. X, y, z to have 1, 1, 1. So in that case, sum will be 3. X plus y plus z will be 3. So sum cannot be 1. There is no such case. Similarly, it cannot be 2. If sum is equal to x, y, z, the only possibility will be 2 into 1 into 1. Again, sum cannot be 2. So 2 is also not possible. 3. Again 3 is not possible. So only possibility is 3 into 1 into 1. So even here we will have sum as 5. So that is not possible. So sum is equal to 4. Sum is equal to 4. In that case, we will have 4 into 1 into 1 as one option. That again sum will be 6. So that is not there. So 2 into 2 into 1. So again sum will be 5. That is not also possible. So even 4 sum is not acceptable. So let's think about sum 5. When 5, the only factorization possible is 5 into 1 into 1. Again, sum is 7. So even that is not possible. Now let's see sum 6. So here the factorization of 6 is 3 into 2 into 1. As you can see, sum of sum is 6. Some of these are 3 plus 2 plus 1 is 4, 5, 6. So this is possible. This sum is possible. So when 1 and 2 are true, 3, 2 into 1 is possible. So that means we can we will think about the numbers that we can make with 3, 2 and 1 as x, y, z. So x and y, z can take any value from this. So total possibilities will be 1, 2, 3, 1, 3, 2, 2, 3, 1, 2, 1, 3, 3, 1, 2, 3, 3, 2, 1. So these are the numbers that we can make with 1, 2 and 3. So as you can see, in all these cases, sum of the digits will be 6. Now we have to pick the numbers where this number will be itself divisible by 6. So sum of the digits in all these cases is 6. And that sum is equal to the product of the digits also. So statement 1 is satisfied in all these cases, and let's see whether statement 2 satisfies for any of these numbers. So so for that statement 2 to be true, the number has to be divisible by 6. So to check the divisibility by 6, we know that we should check it should satisfy the divisibility by 3 and 2. So the number has to be divisible by 3 and 2. So to check the divisibility by 3, the sum of the digits should be divisible by 3. So as you can see, all these numbers, the sum is 6 and that is divisible by 3. So all these numbers are divisible by 3. And now let's see which numbers are divisible by 2. So ones ending with 2 are divisible by 2. So 132 is divisible by 2 and 312 is divisible by 2. So as you can see, that implies if you take 132 and 312, it satisfies, these two numbers satisfy both statement 1 and statement 2. That is, statement 1 is what? X plus y plus z. X plus y plus z is equal to x into y into z. So as you can see, 1 plus 3 plus 2 is 6. 1 into 3 into 2 is also 6. So statement 1 is satisfied in both these cases. And statement 2 is what? Statement 2 is x plus y plus z is the number is itself divisible by 6. As we have seen, we selected these two numbers which passes the divisibility test by 6. So 132 and 312 are both divisible by 6. So statement 2 is also satisfied. And as you can see, even after using statement 1 and statement 2, we are not able to arrive at a single answer. Both 132 and 312 satisfies these two situations. So we will not be able to find the answer using statement 1 and 2. That is what this means. So we only took sum as 6. We could have checked some 7, some 8 and all, but even when we check for sum 6 itself, we are getting two potential answers that satisfy statement 1 and 2. So that itself makes it clear that the statement 1 and 2 together, even if we use it together, we will not be able to find the number. So the answer will be D. The question cannot be answered even by using both the statements together. So solution to question 37 is D. An example is this. Using this example, we can show statement 1 and 2 together cannot help us to find the number. So solution to question 37 is D. Next question, question 38. For 5 children with ages A less than B less than C less than D less than E, any two successive ages differ by 2 years. What is the age of the youngest child is the question. Statement 1 is the age of the eldest is 3 times the youngest. Statement 2 is the average age of the children is 8 years. Which one of the following is correct in respect of the questions and statements? Option A is the question can be answered by using one of the statement alone but cannot be answered using the other statement alone. Option B, the question can be answered by using either statement alone. Option C, the question can be answered by using both the statement together but cannot be answered using either statement alone. Option D, the question cannot be answered even by using both the statements together. So these are the options. So we will analyze what is given. So any two successive ages differ by 2 years, and we have 5 years in the order A less than B less than C less than D less than E. So in that case, we can assume the ages as x plus 2, x plus 4, x plus 5, sorry, x plus 6. So there are 1 2 3 4 5 ages, 1 2 3 4, and x plus 8. So these are the let these be the ages, x be the lowest and x plus 8 being the oldest. So each one, as you can see, differs by 2 ages. Successive ages, if you see, each one differs by 2. So this is the ages. Let's analyze the first statement. The age of the eldest is 3 times the youngest. So it is given age of the eldest, that is x plus 8, is 3 times the youngest. So from this alone we can see 2x 2x is equal to 8, that implies x is equal to 4. So we can find the age of the youngest child from statement 1 alone. So x is equal to 4, we get the age of the youngest as x is equal to 4. So statement 1 alone is sufficient to find the age of the youngest child. So we will see statement 2. In statement 2, the average age of the children is 8 years. The average age of the children is the middle one's age. So since these are successive ages, 1 2 3 4 5, the middle one, x plus 4, will be the average. So x plus 4 is given as 8 years. So which also gives x is equal to 8 minus 4, which is equal to 4. So this also, statement 2 also helps us to find x is equal to 4, that is youngest age is 4. So statement 2 alone is also sufficient to find the age of the youngest child. So the correct answer will be the question can be answered by using either statements alone. So B is the correct answer. So solution to question 38 is B. The question can be answered by using either statement alone. Next question, question 39. A cuboid of dimension 7 cm into 5 cm into 3 cm is painted red, green and blue color on each pair of opposite faces of dimension 7 cm into 5 cm, 5 cm into 3 cm, 7 cm into 3 cm respectively. Then the cuboid is cut and separated into various cubes, each of side length 1 cm. Which of the following statement are correct? First statement, there are exactly 15 small cubes with no paint on any face. Second statement, there are exactly 6 small cubes with exactly 2 faces, one painted with blue and the other with green. Select the correct answer using the code given below. So 1 only, 2 only, both 1 and 2, neither 1 nor 2. That are the options. So we'll just draw a figure. So sorry, I'll just draw a cube. Let this be 7. This be the smaller side, 3, and this be 5. So this is our cube. So with this side 7, this side 5, and this side 3. So it is given 7 into 5 centimeter is painted red. So this is red here. So this side will also be red, and 5 into 3 centimeter. So 5 into 3, 5 into 3. This is 3. So 5 into 3 is this. 5 into 3 centimeter is painted blue color. Sorry, green color. So 5 into 3 is painted green. So this side will also be green. The hidden side, this is green. This is also green. Sorry. So this is also green, and then this is blue, and this side under will be also blue. So these are the sides So as you can see, this is our cuboid in question. Now let's look at the statement 1. There are exactly 15 small cubes with no paint on any face. So if you are familiar with the cube dissection problems, there is a standard formula to find the number of cubes which have no sides painted, which is n minus when each side of the cube, the length, breadth and height are equal and they are all cut into n different pieces, then the equation is n minus 2 into n minus 2 into n minus 2. So but here the length, breadth and height are different, so this formula changes to L minus 2 into breadth minus 2 into height minus 2, into height minus 2. So here this becomes 7 into 7 minus 2 into 5 minus 2 into 3 minus 2, or 5 into 3 into 1, 15. So number of cubes with no paint on any face is 15. So statement 1 is true. So if you are not familiar with this formula, I have done a video on cube dissection. You can find it on the playlist Basic Concepts of Mathematics in my channel. Please have a look and you will have a better understanding of this concept. So this is 15, and the next question is there are second statement is there are exactly 6 small cubes with exactly 2 faces, one painted with blue and other with green. So what are the cubes that will have one side painted blue and one side painted green? So if you see, this corner piece will have when we cut this corner piece will have blue, red and green. So the middle piece, so since it is only 3 in length, there will be only one middle piece, so which will have one side blue and one side green. Similarly, there will be one middle piece here also with one side blue and one side green. So if you make it transparent, then you can see here also there will be one side blue and this side will be green and this side will be blue. Similarly, here also we will have one cube with one side blue and one side green. So there will be 4 cubes. So this statement is wrong. There will be 4 cubes instead of 6 cubes. So statement 2 is wrong. There will be only 4 cubes with exactly 2 sides painted and one with blue and one with green. So solution to question 39 is A1 only. In this question, if you find it difficult to visualize the cube, then I will use a tool to show you a visual representation of what this question means and how we can find this formula 7 minus 2 into 5 minus 2 into 3 minus 2. So for that, I'm going to use a tool by NCTM. So this is the cube that is referred in the question. So I'll just show you the cube. It has 7 into 5 into 3 sides. So 7 into 5 side is painted red, and 5 into 3 sides is painted blue. Uh, 5 into 3 sides is painted green and 7 into 3 sides is painted blue. So this is how the cube looks. I'll just rotate you and show. And in the question it says the cube is split into smaller cubes with 1 centimeter side. So the lines represent the cuts we have to make to get that smaller cubes. So second part of the question, which was, I will just show you the second part of the question was, there are exactly 6 small cubes with exactly 2 faces, one painted with blue and the other with green. So whether that statement is true or false is the second question. So that can be easily found out from this. I'll just show you the one that got transparent. this one, and one on the other side. These are the cubes that has two sides painted, and one with blue side and the other with green. So in this corner also, if you see, if you rotate, you can see this is this there is another corner where it is painted blue and other painted red. So there are only 4 such cubes with exactly 2 faces, one painted with blue and other with green. So the answer that it has, there are 6 such cubes, is wrong. So just go to the question again. So it was given there are exactly 6 small cubes with exactly 2 faces, one painted with blue and other with green. So it is wrong. As you can see clearly, there are only 4 such cubes, one on the hidden this side. So okay, so there are only 4 such cubes. Okay, that is settled. That is an easier part. So first one was the difficult one. We'll go through it. The question was, there are exactly 15 small cubes with no paint on any face. For that, you have to open up the cube and see what is the number of cubes that is inside, which has no sides painted with any color. So to visualize that, I will open this cube up, show you. So see, this is this I just opened the cube up. So we have green, red and blue sides, and I just cut it open so that you can see this more clearly. So the number of cubes, the cubes with these white color are the ones which has no sides painted. So I have marked it with white color so that you can see that in those cubes it is not painted on either of the sides. So we have removed all the colored cubes and we have opened it up, and this is the number of cubes which has no sides painted. How now here I just opened it up and showed you clearly. In many questions we will not be in the exam hall, we will not be able to do such kind of drawing and all. So we have a formula with us and we will see how that formula came. So for that, let me just, I hope you understood how this cube is opened, how this figure came and how we cut it open so that we can clearly see all the things we want to derive the formula. So I'll just go back to the question and let me try to explain. So this is the one we want. If you see, this is the length and breadth of the cube that we need. Number of cubes, if you consider this as a cuboid or cube, this is the length, breadth and height of the cubes we need. So what is this length? This is nothing but removing one side from here, one side from here. So if you remove one from each sides, and this is the length 7, right? 1 2 3 4 5 6 7. This was 7. So if you remove one from both sides, we'll get this length. So that is how we get 7 minus 2. And what is this? This length is nothing but this height, this breadth, removing one from both sides, and we get this length. So we have 5 minus 2 as our breadth. And now we have our height. What is our height of this? Height is nothing but we have this height and we remove one from both sides. So we get this height. So this height will be 3 minus 2. So the answer will be 5 into 5 minus 2 is 3. 3 minus 2 is 1 and 15 cubes. So if you just count up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. We have 15 cubes with no sides painted. So if you go and check the video that I made on cube dissection, you can see to find in a general case where a cube with length n is cut into n pieces like this. So when n is cut into uh, so length n is cut into cubes of 1 centimeter, so we have n cubes. In such cases we have to find the number of cubes with no sides painted, we use the formula n minus 2 into n minus 2 into n minus 2. So here length, breadth and height was different. So in such cases we will have length minus 2 into breadth minus 2 into height minus 2. So this is how we get that formula. This is the visual representation. This is how we got that formula. Length minus 2 into breadth minus 2 into height minus 2, or if it is length and breadth height are same, we have n minus 2 into n minus 2 into n minus 2 to find the number of cubes with no sides painted. So I hope you understood how this formula came, and once you understand how this formula is derived, you can easily apply this question. You can easily apply this in the questions in the exam, and you without any drawing you can find the answer in a very fast manner. So I hope that is clear. If you still have any doubt, do ask in the comments. I'll try to address it. Thank you. Next question, question 40. What is the remainder if 2 raised to 192 is divided by 6? So this is also a pattern kind of question. So let's see. So 2 powers can be written as 2, 4, 8. 8 into 2 is 16. 16 into 2 is 32, and so on. So if you see, 2 raised to 1, remainder is 2. 2 raised to 2, remainder is 4 itself. From 2 raised to 2 cube, the remainder is, if you divide 8 by 6, remainder will be 2. For 16, remainder will be dividing with 16, 12. 6 into 2 is 12. So remainder with when divided with 6 will be 4. And for 32, when you divide with 6, 6 into 5 is 30. The remainder is 2. As you can see, the remainder repeats. First 2, 4, 2, 4, 2, 4. Remainder repeats. The reason is, if there is a number 2 raised to n with 6k plus 2 as remainder, as you can see, there is a number like this where n is 3. So we can find a number 2 raised to n such that remainder is 2, and when dividing with 6. So what happens when you divide, when you multiply throughout by 2? So 2 raised to n plus 1 is nothing but 6k into 2 plus 2 into 2 becomes 4. So 6k into 2. So as you can see, this 2k is another integer. So 6k1 plus 4. So next will be having 4 as the remainder. Similarly, this cycle repeats. If you multiply throughout again by 2, we will get 2 raised to n plus 2 as 6 into k into 2 plus 4 into 2, 8. 8 can be written as 6 plus 2. So this again adds with this. So this is again so 6 into k1. So this can be written as 6k2 plus 2. So as you can see, the remainder repeats. It becomes 2, then 4, then again 2, then the whole process repeats. That's why remainder is repeating. So the only thing we have to do find is whether if you see 2 raised to 1, 2, 3, odd number. If it is an odd number, remainder will be 2, and if it is an even number, the remainder will be 4. So 2 raised to 192. 192 is an even number. So remainder will be 4. So solution to question 40 is D, 4. Next question, question 41. Consider the sequence ABC underscore underscore ABC underscore DABBCD underscore ABCD that follows a certain pattern. Which one of the following completes the sequence? So if you see, here there is 2B, ABC, and here it is starting again. So here there is 2 letters, then there is 2 letters. So if you see, the pattern here is ABCDD. If you put DD, and here it is CCD, so AB, CCD, and here ABBCD, ABBCD, and so here it will be AABCD. So each there is 2 letters repeating like this. Okay, that is the pattern here. So the blank will be here DD, DD, and here it will be C, and here it will be A, DDCA. So DDCA. So correct solution to question 41 is D, DDCA. In case if you are not able to find any pattern in the exam hall, try putting in such question, try putting the options in and see whether you see any pattern then. So just that is plug in these options. So we'll have to write 4 different cases. It will be little time consuming, but still you will be able to see whether there is any pattern if you plug the options in. So that is one method you can solve such questions. Otherwise, do many problems, then you will start to see the patterns in much faster in exam hall. So yeah, anyway, solution to question 41 is D, DDCA. Next question, question 42. AB and CD are 2-digit numbers. Multiplying AB with CD results in a 3-digit number DEF. Adding DEF to another 3-digit number GHI result in 975. Further, AB, CD, EF, GHI are distinct digits. If E is equal to 0, F equal to 8, then what is A plus B plus C equal to? So I'll just note down what is given. So AB into CD results in a 3-digit number DEF, and adding DEF with a 3-digit number GHI gives 975. This is the information that is given. Here it is multiplication and here it is addition. So it is given, it's also given E equal to 0 and F equal to 8. It is also given A, B, C, D, E, F, G, H, I are distinct digits. So from this we can see F plus I is equal to 5. If here F plus I equal to 5 means we already know F is equal to 8. So F is 8. So 8 plus I equal to 5. So for this to have 5, this has to be 15. Since even if I is 9, it will be less than 17. 9 plus 8 is 17. So it has to be less than 17. So it will not be 25. It will be 15. So 8 plus I is 15. From this we have I is equal to 7. 15 minus 8, which is 7. So we got our I as 7. Now as you can see, E is 0. So there is a carryover. So what do we have? So we will have E D0 8 G H I we got as 7 is 975, right? And there is 8 plus 7 15. There is a carryover. So H plus 1 is 7. So H plus 1 is 7, or H is equal to 6. So we got H as 6. So now D plus G, there is no carryover. So D plus G is 9. So D plus G is 9 means already, so what are the numbers? So if D or G is 9, then the other number has to be 0. Since E is already 0, it will not be possible since all the digits are distinct. E is already 0. So D and G cannot be 0. So D and G cannot be 9. and already 8 is taken by F, so 8 D and G cannot be 8. 7 is also taken, so D and G cannot be 7, and H is 6, that means D and G cannot be 6. So the only possible combination will be then 5 plus 4. So D and G has to be 5 plus 4. Whether D is 5 or G is 5, we don't know. All we know is D, G will be number from 5 and 4. Either D is either like this 5 4 or 4 5. We don't know which one, but that is the only possibility. So what are the numbers left for A, B, C? Now A, B, C, the numbers 0, 1, 0 is taken. 4, 5 is taken, 6 is taken, 7 is taken, 8 is taken. So the only number that is left for ABC to take are 1, 2, 3 and 9. So as you can see, we got our DEF. DEF is either 408, or if D is 5, it is 508. So if AB into CD, in AB into CD results in 408 or 508. We don't know, but 408, either 2. So that itself makes it clear that A, B, C cannot be A and B, C. Sorry, A and C cannot be 9. So what is wrong? So if A or B is 9, that means the smallest possible combination will be something like 91 into 24. So 91 into 24 is far higher than 408 and 508. So any number 91 into 10 itself is greater than is 910. So this number will be much higher. So the A and C cannot be 9. So that we can rule out that possibility. Now whether B can be 9 is what we need to know. So as you can see, we'll think of that possibility. Let A, B be 9. If in the case of B, be 9. So C, and we have F as 8, and here we have 0. So if for this to be true, this has to be either 4 or 5. Both can be the case. We will check whether both satisfy, whether that satisfies, and we will get 8 here. If 9 into 4, if 4 comes here, 36. 9 into 4 is 36. So 8 cannot be the last digit, so that is not possible. So 4 cannot come here. And what about 5? 9 into 5 is 45, right? So 8 cannot come here. So B cannot be 9 also. So what that means is ABC has to be from 1, 2, 3. 9 is ruled out. In none of these positions, 9 will be there. So it has to be from 1, 2, 3. So that means A plus B plus C is 1 plus 2 plus 3, 6. There is no other case where this gets satisfied. We don't want to find exactly whether A is 1 or 2. Of course, we can find out, but that is not needed. So the case will be probably this. Let's see, 4 into 2 is 8. 12 into 34. What is 12 into 34? 34 into 10 is 340, and 68. 408. So we get 408. So 12 into, so A is 1, B is 2, C is 3. So we don't need to find that. I just, out of curiosity, just checked. So our solution is A, 6. So solution to question 42 is A, 6. Next question, question 43. Consider the following statements in respect of 5 candidates P, Q, R, S, and T. 2 statements are true and 1 statement is false. True statement: one of P and Q was selected for the job. False statement: at least one of R and S was selected for the job. True statement: at most 2 of R, S, T were selected for the job. Which of the following conclusion can be drawn? 1. At least 4 were selected for the job. 2. S was selected for the job. Select the correct answer using the code given below. So let's analyze the statements. There are 3 statements given. 2 are true statements, 1 is false statements, and they are asking which of the conclusion can be drawn. So we will analyze the statements. First statement is a true statement, which says one of P and Q was selected for the job. So it says P or Q. One of P and Q was selected for the job means either P was selected or Q was selected, not both. So P or Q, that is the statement that we know. Second statement is a false statement. At least one of R and S was selected for the job. How this statement can be false? At least one of R and S was selected for the job can be false only if both R and S got rejected. So if at least one or both were selected, this statement would have been true. So here at least one of R and S was selected for the job is false only if R and S was both rejected. So this is what we get. This is the information we get from this false statement. So third statement is at most 2 of R, S and T were selected. So we already know R and S got rejected, and now at most 2 of R, S and T were selected is given. So at the maximum 2 was selected is the given. So since at most 2 of R, S and T were selected means since R and S got rejected, T could be selected. T could have been selected, but we are not sure. We cannot say for sure T got selected. Since at most means none could have been also selected. If none of these 3 were selected, then also at most 2 of R, S and T were selected for the job becomes true. So at most means at the maximum. You can read at the maximum here. At the maximum 2 got selected from this. 0 is also at within that at the maximum. So none could have also been selected, but T could have also been selected. That we don't know. We already know R and S got rejected. So we don't know anything from this. So this is the given statement. So we'll see what conclusion we can make out of all these 3. At least 4 were selected for the job. 1 got selected out of P or Q, that we know, and these 2 got rejected, and we are not sure about T also. So we cannot say at least 4 were selected for the job. That is a false statement that we cannot not false statement that we cannot conclude from the given statements. We cannot conclude one from the given statements. Next, S was selected for the job. We clearly know S was not selected since it is a false statement. So at least one of R and S was selected is a false statement means S was not selected. So S was selected for we cannot conclude that S was selected for the job. So the correct answer is D, neither 1 or 2. So solution to question 43 is D, neither 1 or 2. Sorry for the background noise. So yeah, solution for question 43 is D. Next question, question 44. Let P, Q, R, S and T be 5 statements such that A, if P is true, then both Q and S are true. So if P, then Q and S. Second statement is if R and S are true. So if R and S, then T is false. Then T is false. Which of the following can be concluded? So first statement is if T is true, then at least one of P and R must be false. If Q is true, then P is true. That is the 2 statements. So let's see. So if you analyze the first statement, if T is true, so it is given T is true. So if T is true, at least one of P and R has to be must be false is the statement. So we cannot say there is no relation between T to R, S or T to P whatsoever. So we cannot make this statement. We cannot say anything of this is true. So only if R and T, if T is false, even if T is false, we cannot say R and S are true for sure. this the backward relation is not possible, so only forward one. So if R and S are true, we can say T is false. So T could be false in different scenario also. So sorry, if T is false, it does not necessarily mean R and S are true. So it only means if R and S are true, then T is false. So there is no relation between T and R and T and P. So if T is true, then at least one of B and R must be false is a false statement. So if Q, second statement is if Q is true, then P is true. Again, we cannot make any relation from this side to this side. So if Q is true, then P can be true or false. So I will show you how. I will show you an example. From this statement, if you write a diagram, we know that P true means Q S is both true. If P is true, then both Q and S are true. So if P is false, we don't know what happens to Q and S. It is only given if P is true, Q and S are true. It could be true, or it could be false, or it could be false. We don't know. We have no information. So since this is the situation, we cannot make a relation between Q and P. So only this relationship, when P is true, Q and S are true, is the only relationship that can be made from the first statement. So none. So since we have Q in the right hand side, then after then and T on after then, we cannot make any relationship, and none of the statements can be concluded from the given statements. So correct answer will be D, neither 1 nor 2. So solution to question 44 is D, neither 1 nor 2. Next question, question 45. The letters of the word incomprehensibilities are arranged alphabetically in reverse order. How many positions of the letter or letters will remain unchanged? So we'll just write incomprehensibilities first. Incomprehensibilities. Okay, incomprehensibility. So now we will arrange each words in alphabetic order. We can see B. There is no A here. There is one B. So there is only one B, right? B. You wrote B, and there is one C. C. You wrote. Is there any D here? No. There is an E. There is how many E's? 1, 2, 3 E's. So E, E, E. There is no F. There is no G. There is no G. There is one H. One H. G, G, H, I. 1, 2, 3, 4. 4 I's. No, 5 I's. 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. There is no J, K, L. There is one L. M. There is only one M. There is how many N? 1, 2, 2 N's. Right? 2 N's. 11 O. There is one O. There is one P. There is one R. There is two S. There is two S. There is one T. So we have written it in the reverse order. So as you can see, the question is how many positions of the letters will remain unchanged. So changed, 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 unchanged, changed, unchanged, uh, changed, 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 changed. So there is only two letters that remains, the positions remains unchanged, these two combinations, so unchanged. So answer will be C. Solution to question 45 is C, 2. Next question, question 46. Raj has 10 pairs of red, 9 pairs of white and 8 pairs of black shoes in a box. If he randomly picks shoes one by one without replacement from the box to get a red pair of shoes to wear, what is the maximum number of attempts he has to make? So again, we'll write down what is given. He has 10 pairs of red shoes. 9 pairs of, so 10 pairs means total 20 red shoes. 9 pairs of white, that means 18 white shoes, and 8 pairs of black shoes, 8 pairs, that is 16 black shoes. Now we are Raj is picking up shoes one by one randomly, so we have to think about the worst case scenario and see in that scenario what is the minimum number he has to pick to get one pair of red shoes. So let's assume when he starts to pick up, he gets the white shoes as first, which he doesn't want. That makes it a worst case scenario. So he picks up all the 18 white shoes as first. That is the worst case scenario that can happen in a random event. So then when he hopes to get a red shoes, he start getting black shoes, and all the shoes he picks, 16 shoes of black he gets. This combination can happen in either way. First he get white, then black, then white, then black, then white, then black. It doesn't change. It is a worst case scenario. After picking 18 plus 15 shoes, he doesn't get not even one red shoe. That is a worst case scenario. Now all the white and black shoes are exhausted. Now the next shoe he picks has to be red. Since he wants two shoes to be a pair, he needs to pick up two shoes to get one red pair. So this is the minimum number he has to pick to ensure that when picking up randomly, this will ensure at least one pair of red shoe. So what is this number? 10 plus 6, 16. 1 plus 2 plus 3, 36. So 36 is the number of shoes he must attempts. So what is the maximum number of attempts he has to make? Is the worst case scenario, is the minimum number in the worst case scenario. Maximum number of attempts he has to make is the minimum number in the worst case scenario. So question 46, solution is B, 36. Solution to question 46 is B, 36. Next question, question 47. In how many ways can a batsman score exactly 25 runs by scoring single runs, fours and sixes only, irrespective of the sequence of scoring shots? So the numbers he can score at one time will be 1, that is single run, or 4 or 6. So we'll split it into different cases. We'll think from the 6 perspective. So number of times he can score 6 will be at the maximum 4 times. So let's say 4 sixes. So just so we'll just 4 6 will be 6 into 4, 24. He already scored 24 runs. So 4 6 means 24 runs. the number of ways he can score, the remaining one will be one way. So one way, there is only one ways. Similarly, say if he scored 5 6, it would have been greater than 25, so that is not possible. So similarly, if he scores 3 6 3 6, he will get 18 runs. Now that is left is in 25 he needs 7 more runs. How many ways he can score 7 runs using 1 and 4? So we will see that. Let's think, let's split this into cases, different cases. That is scoring 1 1 0 1 0 1. So sorry, let's think from the force perspective now. We can score either 1 4 or 0 4. So 0 4 or 1 4, that is the only ways, right? If he score 2 4s after scoring 3 6s, it will be greater than 7 and he will score higher than 25. So 0 1, there is only 2 ways possible. Similarly, 2 6s, if he score 2 6s, he will get 6 into 2, 12 runs. So the runs that is left is 13. So 13 can be scored with 4 can be 4 different scores of 4 will be 0 4s. 0 4s means what? All the 13 runs are scored by single ones. So that is what 0 4s means. Or he could score 1 4 and rest single runs, or 2 4. Similarly, 4 into 3 is 3 4. 4 into 3 is 12. So 12 is the 3 is the maximum force he can score after scoring 2 6s. So if he score 4 6s, it would have been 16, which is greater than 13. So these are the different force that can have. So 1 2 3 4. So 4 ways. Now 1 6. 1 6 means he scored 6 runs. Rest is rest 19. 19 plus 6 is 25. So he has to score 19 runs. So he can either score 0 4s, 1 4, 2 4, 3 4, 4 4s, 16, and 5 4s means 5 into 4 is 20. So which is greater than 19. So this is the only possible. So number of ways is 1, 2, 3, 4, 5. So 5 ways. So 5 ways. So 0 6s, in 0 6 case, 0 runs by 6. So 25 runs he has to score using 4 and 1. So here we have 25 0 1 2 3 4 5 and 6. 6 score means 24 runs, and 7 score means 7 into 4 is 28, which is greater than 25. So he cannot score 7 4s. So these are the total possible ways. So how much? 7 ways. 7 ways. So total number of ways is sum of all this. So 7 plus so 7, the total is, total ways will be 7 plus 5 plus 4 plus 2 plus 1. What is that? 7 7 plus 5 is 12. 12 plus 4 is 16. 16 plus 2 is 18. 18 plus 1 is 19. 19 ways. So total ways he can score 25 using 1 4 6 are 19 ways. Solution to question 14 is B, 19. So I hope you understood this notation. What I have written here is different scenarios of sixes we take, and the rest is marked. The score he scored using 6 is written here, and in the bracket that is left to score using 1 and 4 is written, and different force we can use to score the value written in bracket is what I have written here. So I hope that notation is clear, and we have found out different ways. So total 19 ways. So solution to question 47 is B, 19. Next question, question 48. In an examination, the maximum marks for each of the 4 papers, namely P, Q, R and S, are 100. Marks scored by the student are in integers. A student can score 99% in n different ways. What is the value of n? So this is an interesting question. I'll discuss two ways to solve this question. And first one is the simplest way or shortest way, I would say, not simpler, but shortest way to solve this. That is using the concept of combination with repetition. I'll discuss how. So it is said the student needs to score 99 percentage mark. So what does that mean? There is 4 papers, PQRS. Each paper is 100 marks. So total marks is 400. And if he scores 99 percentage marks, that means 99 percentage of 400 is nothing but 396. He will be losing 4 marks. He has scored 396 marks and he is losing 4 marks. It doesn't matter whether he loses the entire 4 marks in P, or he distributes that 4 marks, like 1 mark from P, 1 mark from Q, 1 mark from R, 1 mark from S. It doesn't matter. He just has to lose. He has lost 4 marks, and in what all ways he can lose 4 marks in these 4 papers is the question. So this is a classic case of combination with repetition. That is, we have to select 4 papers. The 4 papers can be P itself, or it could be PQRS, or 2 P's and 2 Q's, or 1 P, 1 Q, 2 R's and 1 S. It doesn't matter. We just have to pick 4 from it, and 4 papers from this, and repetition is allowed. This is the classic case of combination with repetition. Combination with repetition formula is n plus r minus 1 c r. Here n equal to 4 and r equal to 4. So that means 4 plus 4, 8 minus 1, 7 c 4. C r is 4. So we get 7 c4 is 5 into 6 into 7c4, which is 7 into 6 into 5 into 4 by 4 into 3 into 2. So 4 gets cancelled, 2 gets cancelled with 6. So 7 into 5, which is 35. So we get our answer straight away as 35. So solution to question 48 is D, 35. So this is, so if you are not familiar with this concept, combination with repetition, I have done a video on this topic, permutation and combination. You can find that video in my playlist, basic concepts of mathematics. There is a video permutation titled permutation and combination. I have discussed this case in detail there. You can check out if you want to learn about this combination in this case. So this is one method. As you can see, you can get to the answer in just one step. So I will discuss another method. So as I said, 4 marks. The question is asking how many ways we can lose that 4 marks if you have 4 papers. So one way is, so first case will be losing 4 marks entirely in one paper itself. So either in P or Q or R or S. So if you have only one paper to choose, our marks will be somewhat like this. I'll just write 96, 100, 100, 100, right? Whether this is P, Q, R, S, we don't know. Now we can use the combination. 96 can go in whether in P or Q or R or S. So total how many ways? Just 4C1 or 4 ways. We have 4 ways to do this. Now let's assume this is losing entire marks on one paper. We can do that in 4 ways. Now let's think we lose the entire marks in 2 papers. That is, we will have 98 and 98. Then we will have 100, 100. How many ways we can permute this combination? It is permutation with repetition. So this is nothing but 2 identical cases. So 4 factorial by 2 factorial into 2 factorial. So when an item is repeating 2 times, we will divide it with 2 factorial. Then the second item is also repeating 2 times, then we again divide with 2 factorial. So we get 4 factorial by 2 factorial into 2 factorial is 4 into 3 into 2 by 2 into 2. So 6 ways. We get 6 ways as our answer. So now let's assume we have already dealt with losing 4 marks in one paper, losing marks in 2 papers, and then losing marks in 3 papers. That will be like how we can lose marks in 3 papers. If for that we have either we will lose either like this, that is 97, okay, there is one more case I haven't discussed. Losing mark in 2 papers can also mean like this, 97 and that is losing 3 marks in one paper and losing 1 mark in another paper. This is also possible. So if you do this same, the total number of ways will be 4 factorial by only 2 numbers is repeating, so 2 factorial. So we will get 4 into 3 into 2 by 2. So we will get 12 ways. This is also one possible way if you are losing paper like splitting like this. So 2 2 3 1, that is the only split that is possible to split between 2, right? 4 2 2 3 1. Yeah, that is only possible. So now if you think about 3 papers, we can split it like 3 2 2 1. So that is 98. Sorry, not 2 2 1, 2 1 1. So that is only possibilities. 2 2 1 1. So 98, 99, 99, 100. So is there any other split we can make out of 4? No, right? Yeah. So in this case, we'll have using permutation by permutation, we have 4 factorial by none is repeating. So 98, 99, 99 is repeating twice. So 2 factorial again, which is 12. So 4 factorial by 2 factorial will be 12 ways. Now let's think about losing the marks in all the papers. So that means 99, 99, 99, 99. There is only one way to do this. So one way. So total number of ways will be 12 plus 12 plus 6 plus 4 plus 1. So that will be 10, 14, 15. So 5. So 5, 15, 1, 3. 35 ways. So total 35 ways. So as you can see, you can find in this manner also. So but it takes more steps, more calculations. So it doesn't, so if you can choose either way, but if you know combination with repetition, you can do this, solve this question in just one step. So yeah, I have discussed both the step. There may be other ways to solve this also, but yeah, these are the two ways we can solve this. So in case if you are not familiar with this 4 factorial by 2 factorial and 2 factorial, just just have a look at the video I have done on permutation and combination. You can find that video on the playlist, basic concepts of mathematics, in my channel. I have discussed the different cases of permutation and combination in detail. Even if you have no prior knowledge about the topic, you will be able to follow that video, and you will if you follow it thoroughly, at the end of the video you will have enough knowledge to solve all the questions that come from this topic in the CSAT examination. So in case if you are getting confused by this answer, do check out that video, and if you have still doubt, do comment. I will try to address it. So this is the solution to question 48. Solution is D, 35. Next question, question 49. A flag has to be designed with 4 horizontal strips using some or all of the colors red, green and yellow. What is the number of different ways in which this can be done so that no 2 adjacent stripes have the same color? This is the question. So we have 4 stripes, 2, 3, 4. So these are the 4 stripes that we need to paint. So we have 3 colors, which is red, green and yellow. So what we are going to do is paint these stripes in successions, so that after first color we'll paint second color, then the third color, and then fourth color. So we will have different choices to do that, and once we have different ways to do that, product of all those numbers will give us total number of ways of coloring the 4 stripes. So as you can see, the first stripe will have 3 choices. We can color any 3 colors for the first stripes. So once that is done, when we go to paint the second stripe, we have only 2 choices left. So we choose one, say randomly we chose one for red for the first stripe. Then second stripe can be painted only with green or yellow, because it is given that no 2 adjacent stripes have the same color. So it should not have the same color as this. So we will be painting either green or yellow. So we are only left with 2 choices. No matter which one we choose for first stripe, we will be left with only 2 other choices. So we will have only 2 choices for painting this stripe. Now we are moving on to the third stripe. What is the restriction? So here there will be some color painted here, right? Out of these 3 color, one color will be painted for the second stripe. That color should not occupy here. So we will be again left with 2 choices. So we have 2 choices to paint here. Now we are going to fourth. Again we will be left with 2 choices. It should not be colored with the color that is painted here, and then we will be left with 2 other colors, then that will be painted here. So what is the total number of ways we can paint these 4 stripes? That will be 3 into 2 into 2 into 2, which is 8 into 3, which is 24. So totally 24 ways. That is solution to question 49 is C, 24. So since we painted it in succession, we don't have to worry whether this stripe will have the same color as this, since we only thought about the color on the top, right? But we are painting in succession like this, so we will never have the bottom one will never be same as top one. We made sure that that condition is not violated. So this will be the case. In case if you are not understanding why 3 into 2 into 2 into 2 is the total number of cases, I advise you to again visit the video on permutation and combination. I am discussing fundamental principle of multiplication is what we use here. If you are not familiar with that concept, just you can find that permutation and combination video in the playlist basic concepts of mathematics in my channel. You after if you see that video, you will have a better clarity, I hope. So yeah, solution to question 49 is C, 24. Next question, question 50. A rectangular floor measures 4 meter in length and 2.2 meter in breadth. Tiles of size 140 centimeter by 60 centimeter have to be laid such that tiles do not overlap. A tile can be placed in any orientation so long as its edges are parallel to the edges of the floor. What is the maximum number of tiles that can be accommodated on the floor? That is the question. So I'll draw the rectangle. A rectangle is somewhat like this, with 4 meter into 2.2, that is 400. So 400 meter, and this is 220. So somewhat like this. So this is how our rectangle. So we so since this is 400 meters, so our tiles can be either placed like this, or with the 140 into 60, or like this. These are the two configuration we can place. We cannot place it in a diagonal manner or nothing. The edges has to be parallel to the floor. So this is not possible. Only this and this is possible. So since we have a lengthier our tile, one of the edges is 140 centimeter. We will try to accommodate it as much as possible in this manner. So 140 and 60. So we'll place our first tile here like this. So 140 centimeter. Again we'll place 140 centimeter tile. So 140, tile 2. So can we place one more 140 here? No. The reason is, so I have drawn it little big. So reason is 140 plus 140 is 280. One more 140 means it will be more than 400. So it will be 320, right? So it will be 420. So it will be more than 400. So we cannot place a tile like this in a horizontal manner. So what is left? The 280, and here 120 is left. So I'll just draw like this. This is 120. Sorry. So 120 is left here. Now we'll place this is 60. So we'll place one more 3, 4. So 60 plus 60 is 120. So we can place one more 5, 6, again 60. So 60 plus 60 plus 60 is 180. So there is only 20 left. So we cannot place any tiles in the bottom. So again I have drawn it too big. So it will be somewhat like this. So there is only 20 left. So we cannot place one more tile in the bottom. So here we can place one horizontal tile like this. 60, 60 and 140. So it will be somewhat like this. Okay, right? So this will be our 7th tile, 60 and 140. So again one more tile we can place, 8, 140. So this is 140. Now we will not be able to place any other tiles in this. So totally 8 tiles we can place. Here what is left? This is 120. This is 120. 120, and here space left is 60. So we'll not be able to place any tile here. So if there was 20 more centimeter, we could have placed one tile here. So here no tile will get fixed. So total 8 tiles can fit in this area. So solution to question 50 will C8. So solution to 8 tiles can be fixed in that given area. Next question, question 51. There are 5 persons P, Q, R, S and T, each one of whom has to be assigned one task. Neither P nor Q can be assigned task 1. Task 2 must be assigned to either R or S. In how many ways can the assignment be done? So we have P, Q, R, S and T. So it is given task 1 cannot be assigned to P or Q, and task 2 must be assigned to either R or S. So we'll split it into two cases. First case is assigning task 2 to R. Now we will see what are the possible ways we can assign the rest of the task to P, Q and S and T. So we'll do the assignment in succession. So P can have how many? There are one task is already assigned. There is 4 tasks left, which is 1, 3, 4, and 5. These are the tasks that is left, and task 1 cannot be assigned to P. So only 3 possible combination, which is 3, 4, 5, are the possible combination P can take. So once P is assigned, again Q, say one task is eliminated, one of this task will be eliminated, and one cannot be assigned. So Q can take only now 2 tasks. So 2 tasks has been assigned to P and Q, and 1 task to R. And what is left? For S, there is 2 tasks left, including 1 that can be assigned to S. So two more tasks can be assigned. So for T, all the 4 tasks has been assigned, only 1 task is left, so only 1 choice for T. So if this is the case, total number of ways we can do this will be what? 3 into 2 into 2 into 1. See, this is not, this is an assignment, so it should not be multiplied. So 3 cases into 2 cases into 2 cases into 1. So 3 into 2, 6, 6 into 2, 12. So 12 ways. So same, this is when 2 is assigned to R. Now let's assume 2 is assigned to S. Task 2 is assigned to S. So same situation. So P can be again filled with 3 tasks, 2 tasks. R can be filled with 2 tasks, and T will be 1 task. So 3 into 2, 6, 6 into 2, 12. So 12 ways. So total number of ways will be 24. So total number of ways we can do this, satisfying the criterions that task 2 goes to either R or S, and task 1 doesn't go to P or Q, is 24 ways. So total 24 ways. So solution to question 51 is D, 24. If it was not clear why we took 3 into 2 into 2, I suggest you to check what is fundamental principle of multiplication in counting. You can learn about that in the video permutation and combination that I have done in this channel. You can find that video in the playlist Basic Concepts of Mathematics. Okay, so solution to question 51 is D, 24. Next question, question 52. There are large number of silver coins weighing 2 gram, 5 gram, 10 gram, 25 gram, 50 gram each. Consider the following statements. To buy 78 grams of coins, one must buy at least 7 coins. That is statement 1. Statement 2 is to weigh 78 grams using these coins, one can use less than 7 coins. Which of the statements given above is or are correct? So to buy 78 grams, exact 78 grams, so we need 8 grams, right? We need so no other combination. So the only way to get 8 grams is taking 2 grams 4 times. That is 2, 2, 4, 6, 2, 4, 6, 8. So this is the only way we can get 8. If you see, the no other combinations will give 8 as the 8 grams. So this is the only way we can get 8 grams. So we'll need 4 coins for that. Now we need to pick 70 grams. 70 grams, we will pick 150 coins. Now we need 20 more grams, which we need 10 coins. So 4 coins, this is the 5th coin, this is 6th coin, 7 coins. So this is the only possibility to get exactly 78 grams. So 7 coins will be needed to get 78 grams. So statement 1 is at least 7 coins is needed is true. So so next statement is to weigh 78 gram using these coins, one can use less than 7 coins. So so to weigh 78 coins, you could do, say there is a weighing scale like this. So what we can do is use 150 coin, 125 coin, which becomes 75, and 5 coin. So this side will become 80 grams. Now we will put 1 2 gram coin here. So 1, 2, 3, 4. Now this becomes 78 in this side, 78 grams. So So we need, so this is the scale we can set up. So when we place 78 grams, this balance out. So we can say, we can find out whether it is 78 gram. Only placing 78 grams will balance this out. So using such a scale, just with 4 coins, we can set up a scale to weigh 78 grams. So I think that is what they are they mean by this statement. To weigh 78 gram using this coin, one can use less than 7 coins. So yeah, this is kind of weighing scale. I just draw a weighing scale with 2. So I hope you understood, right? This the chains goes like this. 2 places. We placed an 80 here and 2 here. So 80 can be formed with 3 coins, 2 can be formed with 1 coin. So total 4 coins are needed to set up this weighing scale. Sorry, I don't know why I'm drawing such a bad figure. Weighing scale is something like, right, this, right? 80 here, 2 here. So this is the weighing scale I am talking. I'm not sure whether they meant this, but to weigh means something like this. So we can use lesser coins to weigh 78 grams. So that is the idea. So this is also true. So solution to question 52 has to be C, both 1 and 2. So solution to question 52, C. Next question, question 53. Consider the following. A plus B means A is neither small nor equal to B. Since it's a big question, I will just note down as I read. A plus B means, so A plus B means A is neither smaller nor equal to B. Neither smaller nor equal to B. That means A is greater than B. So A minus B means A is not greater than B. A is not greater than B means A is less than or equal to B. Now A into B means A is not smaller than B. A is not smaller than B means A is greater than or equal to B. Now A divided by B means A is neither greater nor equal to B. A is neither greater nor equal to B. That is, A is less than B. Is neither greater nor equal to B. So A is less than B. So next statement is A plus or minus B, which means A is neither smaller nor greater than B. That means A equal to B. So this is what the symbol means. Now we will analyze the statement. The statements given are P into Q. P into Q means P into Q is nothing but P is greater than or equal to Q. So P into Q means P greater than or equal to Q. Next, P minus T. P minus T means P is less than or equal to T. So P is less than or equal to T. T divided by R. T divides R means T is less than R. T is less than R. And R plus or minus equal S means R equal to S. So R equal to S. This is the statement given. Now we will see using this statement whether the conclusions follow. So first is relationship between Q and T. So if you see P is greater than or equal to Q, so P is the larger number here, and P is less than or equal to T. So we can say Q is, from these two relation, we can say Q is less than or equal to T. So this is the relationship between Q and T. So the conclusion was Q plus or minus T, that is Q equal to T. That means Q equal to T. No, that is not true. Q can be less than also to T. So conclusion 1 is false. So conclusion 1 doesn't follow. Now let's see conclusion 2. Conclusion 2 asks about S and Q. So we will see we got Q and T. Now T is less than R. So since q is less than or equal to t, using these two, we can say that q is definitely less than r. So even if q is equal to t, since t is less than r, q has to be less than r. So we got that. Now we know that r equal to s. So from using these two, we have q equal to less than s also. So q is less than s from the given statement. The conclusion was s plus q. What does s plus q mean? S plus q mean s is greater than q, or that means q is less than s. So which is the same conclusion we got here. So conclusion 2 is true. So our answer will be B, only conclusion 2 follow from the statement. So solution to question 53 is B, only conclusion 2 follow from the statement. So that was the last question in the CSAT paper. I think I have covered all the maths based questions. If I have missed out any questions, please do comment under the video. I will try to include that question in my video also. So I hope this video was helpful. If you find it useful, and if you have friends who are writing this exam and are struggling with the CSAT paper, do share with them, and do give feedbacks. All the feedbacks will be much appreciated. So thank you for watching this video. I hope you do great in the coming exams. Thank you.